Right. So what are we interested in logic? Because computer represent everything in binary, right? Set of ones and zeros, everything, right? Even audio, video, images, and so on. So then it process everything by sending those signals related to ones and zeros through Boolean logic gates. Okay, so that is why we are interested in Boolean logic. Actually, this is the most important topic, because if someone asks how does computer process data, simple answer is by sending the signals related to those data in binary format through Boolean logic operations, or apply Boolean logic operations, and you get the resulting signals, which represents different set of ones and zeros, and that is your final outcome for the result. So if it is adding 5 and 3, the result signal represents 8. Okay. So if you have sort of a image, maybe the resulting signal is again the ones and zeros related to image, but maybe you have changed the contrast, change the color, right? So therefore, all those things are happen, whether it's image processing, number processing, text processing, audio processing, video processing, the signals goes through Boolean logic gates. Of course, the circuits built using Boolean logic gates and get processed. So therefore, the most important thing to understand, if you want to understand the computer, how the computer works, is understanding Boolean logic. Of course, if you want to understand computer science, so the most important thing is you understand Boolean logic. Okay. So therefore, first of all, let's understand what is meant by logic. Because Boolean logic is the special type of logic. Okay. So what is mean by logic? Can anyone tell me what is mean by logic according to your understanding? So I'm not asking what is Newton's second law. Okay, so these are open questions. These are pretty much open questions. What is your gut feeling says? Logic is not true or false. So that is not a proper answer. Something to do with critical thinking. So what I'm asking is, what is that something? Yes, logic has some very close relationship with the critical thinking that I accept. So I'm not asking Boolean logic. What I'm asking is, what is logic? Oh, can you explain it in whatever the way you come to your mind? But you must concentrate on what is logic. So what does differentiate human from other animals? Can someone tell me what is the key difference between human and dog, human and cat, human and lion, human and crocodile, human and a fish? What is the key difference? What is the key difference? So they also active, we also active, they also reproduce, we also reproduce, they also walk, we also walk, maybe they swim, maybe we can swim, they also eat, we also eat, they also breathe, we also breathe. What is the difference? So the difference is, so we humans in general have the potential for better logical thinking, better logic processing. Then so your logic processing is better than the dog, your cat, a donkey, cow. So now what I'm asking is, if you think say that humans are superior to dog, so if you are forget about the humans, if you feel like you are superior to dog, if you say that superiority is because of logic, so then you must be able to explain what is logic. Otherwise, how do you say that you know logic? Or how do you say that you are superior to your dog? Or you can just stay in the same level as your dog, because you don't know what is logic. So thinking, so what thinking is not always logic, right? So what I'm asking is what is mean by logic? Oh, just try to give me a reasonable answer. So let's see who can give me the best sort of answer out of those. Of course, every answer has some point, but the key point is still missing. Because no point understanding logic gates and logic circuits if you can't, if you don't have proper answer to what is mean by logic. Identifying connections. So that is reasonably good answer, right? Reasoning. So that is now you are getting into the proper path, right? Reasoning, identifying connection. Of course, identifying connection is sort of a reasoning. So now at least we are getting towards the better answers. Okay. Yes, we can use logic in problem solving in realistic manner, of course. Okay. Right. So what is logic? So logic is the basis for reasoning. So we reason out things using logic. Right? We reason out things using logic. Can you give me a very simple example that involve logic? Just give me the simplest example that comes to your mind, which has something to do with logic. Anyone? So simpler the example, better. But it must have explicit logic. Your statement, your sentence must have some sort of a basis of logic. Anyone? Because as a human, this is the subject you must give the most attention. Because this is what differentiates you from others, other animals. So I'm not asking, I ask you the simplest possible answer, right? So you think that the permutation and combination is the simplest possible example for logic. So remember, think about simple things is the most important ability. Right? So that is not something I told, that is what Einstein told. Right? So Einstein told, right? So this is what Einstein told. So this is what Einstein told, okay, not me. Right? Einstein told. Any intelligent fool can make things bigger and complex. Right? Any intelligent fool can make things bigger and complex. It takes touch of genius, a lot of courage to move in the opposite direction. Now you need to have a lot of courage to come up with the simplest example. Because there will be hundreds and thousands of complex examples coming to your mind, because that any intelligent fool can do. According to Einstein, not by me, okay? Anyone? So this is an example. If you hit me, I will hit you back. There's a logic. Right. So another one. If you run, the dog will chase you. So don't run, stay there. If you run, the dog will chase you. So that is a logic. Because I know about my dog. Dog will chase you. So if you go into a little bit more formality, if you smoke, you may get cancer. Okay, you may get cancer. So that is logic, right? Reasoning. Okay, reasoning. So why you are going to be hit by me? Because you hit me. So that is called logic. That is called logic. Okay, so first of all, you must understand what is logic is. Okay, what is logic is. Yeah, if it rains, you shouldn't get wet. Maybe it's very uncomfortable. Right. So logical statement is is used for reasoning. Right. So the simplest possible logic statement is something like if P then Q. If P then Q. If you hit me, I will hit you back. Okay. If you give me the money, I will give you the product. Okay. If you love me, I will love you back. Those are called arguments. If you hit me, I will hit you back. Okay. Right. So that is called logic. So first of all, understand what is logic is. No point understanding what is that gate, right? What is AND gate, what is OR gate, if you don't know what is logic is. Okay. Right. So there are two types of logic people use. Is logical and critical thinking are the same? No, but they are highly related. Highly related. Right. So critical thinking means you question things. When someone tell you, you don't accept for faith. You don't accept it for faith, or you don't accept it because of the fear. Fear from the society, right? Fear from other, your loved ones, your parents. So they will agree with you. So therefore, sometimes you accept things. So critical thinking is you don't accept something without someone gives you proper reasoning, proper logic, formal scientific logic. So that is called critical thinking. It is not you always asking question. You ask questions when it is required. So mostly you ask questions from yourself. Critical thinkers, they ask questions from themselves first. And if it cannot be resolved, so then they ask questions from others. And finally, they ask the question from the person who give that opinion, give that statement. If that person is not, if I am not agreed with that, according to my critical thinking, so that then I can say, no, I don't agree with you. So this is not a proper reasoning. Right? Right. So that is critical thinking. But when you're doing critical thinking, logical reasoning is your main tool. Because no point asking questions if you are looking for illogical reasons. So then it doesn't work. So therefore, critical thinking is the bigger process. Logical thinking is the main tool in critical thinking. Right. So therefore, logic is reasoning, right? So different people can reason out differently. Different people can reason out differently. So therefore, just because it is logic, it doesn't mean that is correct. Right? It doesn't mean that is correct because
Sir, excuse me, sir. Is that mean logical thinking are not always truth?
yes, because for one person logic is, another person it's not logical, because logical, whether it's logical or not is objective. Okay. Sorry, it's subjective. It depends on the person, right? For example, one person will say I got a small accident. So assume, right? I got a small accident. So one person might say, so you are careless. So that is why you got it. So that is his or her reasoning. That is his or her reasoning. So I observed that these days you are not very careful. So therefore, maybe that is the reason. Another person might be say, okay, that is your faith. Right? That is your faith. So that is also right. Maybe you have done some bad things in the past lives. So therefore, you get the result. So that is another reason. That is also logic, right? Or maybe these days check your horoscope. you are going through a bad time. So that is why these things are happening to you these days. So that is also reason. So then it is up to us to decide, so which logic you accept, which logic you don't accept. So we can't force anyone to saying this is what you should accept, this is what you shouldn't accept. It's up to you. So therefore, learn all these logical thinking. Right? So look, different logical thinkings, learn, and you decide which one you accept, which one is more reliable, which one you reject. Or if you want, you accept everything. Right? So therefore, just because it is a logic, it doesn't mean that it is correct. Because for different people, logic is different thing. So that is why we want to subdivide logic into formal, scientific logic and informal logic. So what we learn is formal scientific logic. And what is happening inside the computer is formal scientific logic. Right? So scientists, engineers, when they are doing their practice their profession, a doctor, so what they use is formal scientific logic. What they are supposed to use is formal scientific logic. Inside the computer, 100% guaranteed it is formal scientific logic that is being processed. Nothing else. Nothing else. Okay. Right. So therefore, from this point onward, when I say logic, because this is IT course, so we talk about formal scientific logic. Okay. So that means it is scientifically backed. We can scientifically proved. It is not opinionated. It is not my opinion, no X opinion, Y's opinion. So those are generally agreed things. Formally agreed, documented, proved things. So we use those things in science, engineering. But informal logic, of course, anyone can come up with research. It's highly opinionated, and set of people will accept it, another set of people will reject it. So that is okay. That is their freedom of thinking. Okay, so those are used in art, cultural, religions, those kind of areas, they use it. So let them use it. And of course, if you want to use it, you can also use it. That is up to you. So no one is going to, right, block your thinking. So that is fundamental rights everyone is having. Freedom to think. Okay. So that is the difference between formal logic and informal logic. So therefore, just because you hear the word logic, don't think that that is always correct, because people use the word logic for different ways. Okay. Right. So why you should learn formal logic? So that is what we learn here. Because you can be a critical thinker. So critical thinkers use formal logic. Formal logic. So then, of course, so that is in general for your life. So then you can apply your formal logic for your profession. Whether you are engineer, doctor, scientist, manager, right? Philosopher. So philosopher again in the sense, realistic philosophers. Okay. Linguistics. Right? For example, some people find learning languages difficult, right? So one of the reasons is maybe you don't see the patterns. You are not very logical thinker. So therefore, you don't see the pattern in that language. So when your logical thinking is really good, when your critical thinking is really good, so there are a lot of advantages. So you can be successful in many areas. Okay, many areas. And of course, this is what differentiate animals and humans. So remember, when you born as a human, you are a logical thinker. Logical thinker means formal logical thinker. Don't think that when you born as a human, you are a critical thinker. Only thing is you have that potential. So you have that potential unless you have any medical condition, right? So you have that potential, but it doesn't mean that you are a critical thinker. Maybe you're not using it, or maybe you are misusing it. Okay. So when it comes to formal logic, remember we are talking about the formal logic, scientific logic. So we can identify again, categorize the formal logic. Now we are not interested in other logics, right? So what are those categories? The number one is Boolean logic. Boolean logic. Two-state logic. So that is the most reliable and most widely used logic. If you take computer, this is the logic, hardware level, 100% use. 100% use, hardware level, in a normal computer. So there are some research purposes, they have developed some special computers. Of course, those computers use a slightly different logic as well because they are doing experimentation. But if you take your smartphone, laptop, desktop, hardware level, this is the logic we use in your microprocessor, Boolean logic. Because this is the most simple, this is the simplest and the most reliable, but it doesn't mean that we can apply Boolean logic everywhere. There are limitations, but within that possible areas, this is the best, if possible. So when that Boolean logic is not possible, there are situations like that. So then there are variations like probabilistic logic, fuzzy logic, and so on. This is a very interesting area. Okay. So if you go for something like AI, artificial intelligence, machine learning, so you will be learning more and more about the probabilistic logic and fuzzy logic. So that is why when you are moving to the AI and machine learning, data science, so your main subject will be probability, statistic. Okay. So you identify patterns. If probabilistically something happens, that happens. So we accept it. We accept it. Maybe we don't know the exact reason, but as a probability, we know that there's a connection between those things. It is not just true false, maybe 20%, 10%. But Boolean logic is two-state. True, false. True, false. So linguistic means there's a question about linguist. Linguistic means the formal scientific way of learning or understanding what are languages, how the languages are formed, how people use languages. Right? So linguistic is one of the most important subjects for computer scientists, software developers, IT professionals, because now you also have a subject called programming. So programming is done using programming languages. Java language, C language, Python language, PHP language. So therefore, linguistic is a very important aspect for anyone because we talk using languages like English, Tamil, Sinhala. That is also linguistic. So then, of course, how we communicate our solutions to the customer, solutions to the computer. And there's another area that is now we can directly talk to the computer. Linguistic. To ChatGPT, you talk. So then how does ChatGPT, Google, Gemini understand what you say? So using the subject of linguistic, with the help of AI, yes, your AI agent can understand what you mean. So that is how they have done it, using linguistic. So there are linguistic models. Okay. If something is formal scientific logic, can an expert in that subject debunk it or prove it wrong with his or her researchers? Of course, yes. Because science is not eternal truth. Science is the best we know right now, right? Especially the natural science. So natural science is because nature is natural phenomena, right? Nature is not something created according to formulas, plans, and so on. Nature is natural phenomena. So when natural phenomena is not perfect, right? So when something is a natural phenomena and it is imperfect, how can scientists come up with perfect rules? Right? So just think yourself. So what the scientists are trying to do is try to get the best out of that, the best available rule. So science is very liberal area. Science is very liberal area, right? So this is our current best knowledge. For example, for some people, some period, people thought Newton's laws are sort of a perfectly correct. But that is not the scientists. Scientists never think that these are perfectly correct. The scientists know that these are just approximations. So then Einstein came with some other theories. But Einstein's theory of relativity is again not the truth. So that is the better explanation about the nature, because nature is not perfect. So when the nature is not perfect, we can most probably never ever scientists will come up with perfect rules. That is almost impossible thing. Right? That is almost impossible thing, because how can we come up with perfect theories when something is a natural phenomena? Right? Of course, if it is made using some predefined plans, design and so on, so then we should be able to come up with perfect theories. Okay, but when it comes to formal science, that is a different story, right? So what I refer is natural science, physics, chemistry, biology, and some other related areas like astronomy and so on, earth science. Nothing is perfect. Just we have the best explanation, best theories right now, best possible right now, or best available right now. But formal science is different story. It's formally man-made knowledge. Okay. So there, the theorems and those things are not challenged. Okay. So for example, Pythagoras theorem is not going to be challenged as long as our thinking is this dimension. Maybe if you think in a different dimension, maybe that is also challenged. Right? So those are some formal notations, postulates, or the axioms, standards, and based on those things, we build another thing, another thing, another thing. So those are sort of a perfect. But again, for our dimension. Okay. So if some other biological creature or something develop and look at those things, maybe they will challenge it. But pretty sure we can't challenge it among ourselves. Okay, so that is the difference between formal science and natural science. So formal science include maths, right? Computer science, theoretical computer science, and so on. So luckily we are doing formal science. So that is why formal science is very easy, because those are sort of a perfect knowledge for our point of view. Okay. So I hope you have some sort of answer, but if you are not very sure, you can ask again. I can explain maybe very specifically. Right. So therefore, at hardware level, computer use Boolean logic. But at software level, through programmatic way, we can use probabilistic fuzzy logic processing also. And of course, the computer engineers are researching on using these probabilistic and fuzzy logic at hardware level as well. Okay. But still those are at very early stages. So that is why we have something like neural networks and so on. So try to understand how the brain works and try to simulate the same thing in the hardware level. But right now, the way our brain works and the way the computer processing work are completely two different things. Right. So the computer do process in a completely different way. Our brain process in completely different way. For example, the way we add 5 and 3 and say 8 is not the way the computer add 5 and 3 and say 8, but both says the same. Both say the same. Both give the same result, but those are processed in two different ways. Our brain hates ones and zeros, digital things. So our brain prefer more analog things, pictorial things. But computer, digital things are much more easier because we heavily use Boolean logic, digital circuits. Okay. Right. So Boolean logic is our topic. So Boolean logic means two-state logic. two-state logic. Two-state logic means when you have an expression or statement, we should be able to say that yes, it is true, or we must be able to say it is false. So if you have that kind of a statement, so we call it proposition, right? Statement which is either true or it is false. So Boolean logic can be applied for that kind of statements only. For example, if I say sun rises in the east, so that is true, right? That is true. Okay. So if I say 5 is greater than 2, that is true. 5 is greater than 2. So if you have any doubts, let's discuss. Because these are formal science things. But I don't want to give a statement like atom is the smallest unit in the universe. No. Because even the scientists have found smaller things. And we never know in 5 years time, they will come up with some other periodic table where it's no longer hydrogen, helium, right? Some other units. Okay. Right. So Boolean logic is two-state. So there can't be something called both true and false, neither true nor false, or there's in between true and false, there's a third state. So then it is not Boolean logic. So then someone will say that, okay, then it is very restrictive, where there are a very small set of usages. So the funny thing is, no, there are plenty of usages for Boolean logic. Right? Actually, most of the usages are Boolean logic. For example, when you go for the exams, either you pass or fail. There's nothing called somewhat pass. Okay. So when you buy something, either you get the discount or you don't get the discount. That's it. That's it. But yes, in real world, there are situations where it is neither true nor false. ඒවට තමයි AI ඕන. So that is probabilistic fuzzy logic first. දැන් ඔයා කායෙන් හරි අහනවා ඔයා මට ආදරේද කියලා. එයා කාට කියනවා නෑ මං ඔයාට ආදරේ. Boolean logic. එලකිරි. නැත්තම් කියව ඔව් මං ඔයාට ආදරේ. නැත්තම් කියයි අනේ මං දන්නේ ආදරේ තමයි ඒ වුණාට පොඩි කුටපට ටිකක් තියෙනවා. So that is not true false, right? Yes no කිව්වේ නෑනේ. So that is not. So there we can't apply Boolean logic. So that is why when you are interacting with humans or other creatures, we need to go for AI. Where it is not 100% Boolean logic, we can process those intermediary states, probability, right? We can reason out in multiple dimensions and so on. So there's a possibility of 10% possibility of this happening, 20% probability of another thing happening. So then it is other fuzzy logic. Okay. So first of all, you must know what you are learning. What are the limitations? What are the usages? Right? Rather than hurried into the concepts and start learning those things without knowing what you are doing. So the funny thing is, some students, they are very busy learning things which they don't know what. Right? So that is crazy. අපි කියන්නේ පිස්සෝ කියලා. පිස්සෝගේ වැඩේ මොකද්ද? පිස්සෝ හරි busy. හරි අරේ යනවා මේ යනවා කතා තමන් එක්කවත් කතා කරන්න හැබැයි ඇහුවොත් එimhe අයියෝ අරේට ගියේ කියලා මිනිහා දන්නේ. ඒකට කියන පිස්සෙක් කියලා. ඒ වගේ තමයි සමහර ස්ටඩි කරනවා නේද? ගණන් ඉගෙන ගන්නවා, කෙමිස්ට්‍රි ඉගෙන ගන්නවා, ෆිසික්ස් ඉගෙන ගන්නවා. එන්න busy. විභාගයට යනවා, ඒ දෙකක් ඒ තුනක් ගන්නවා. හැබැයි ඇහුවොත් එimhe මේ මොකද්ද විද්‍යාව කියන්නේ? මොකද්ද තර්කයක් කියන්නේ? ඒව දන්නේ නැහැ. ඒකට අපි කියන්නේ කවුද කරන්නේ? පිස්සෝ. පිස්සෝ. පිස්සෝ එන busy. හැබැයි චුට්ටක් ඉගෙන ගත්තත් කමක් නැහැ. ඒක හරියට ඉගෙන ගන්න. හරියට ඉගෙන ගන්න. මොකද්ද මේ ඉගෙන ගන්න? මොකද්ද මේකේ ලිමිටේෂන්? මේකේ මොනවද කරන්න පුළුවන්? මේකේ මොනවද කරන්න බැරි? මේක අර තව මොනවද තියෙන්නේ මේකට විකල්ප? So that is what studying is. Right. So from this point onwards, we are 100% concentrating on Boolean logic. Why? Because that is what we use in computers. So we are doing computers, information technology, computer science. Right. Another name for Boolean logic is propositional logic. Because we can apply Boolean logic operations to propositions. nothing else. Right? So don't apply Boolean logic to anything else. So apply Boolean logic to propositions only. This is proposition, not preposition. Preposition is a topic in grammar, English grammar. Okay. Weather reporting is probabilistic logic. Yes, weather reporting is probabilistic logic. So that is why they say there's a 10% of possibility, right? So you can see if you go to the weather report today, weather.com. So you can see 95%, 92%. So this is day by day. Okay. So again, you can see time wise. So it's a probabilistic logic. Right? Probabilistic logic. Then someone will say, how do they say sometimes 100%? So 100% means again, it doesn't mean that if it is 100%, it doesn't mean that definitely trained. Okay, definitely trained because they are just giving it for example, so say your weather report says 100% chance rain in the Colombo area, but you know that Colombo is a very big area, right? So therefore, maybe some rain in Colombo 3, but no rain in maybe Nukewad area, or Colombo 5, or Colombo 8. So therefore, you need to take it in the proper context, right? But you know that probability is high means there's a higher chance, probability is low means there's a lower chance. It is not just true false. They don't say rain, not rain. So there is a 50-50, 80%, 60%, 30%, and so on. Okay. Right. So what is a proposition? A proposition is a statement which is either true or it is false. So the other thing is you must know why do we call this logic Boolean logic, two-state logic or proposition logic as Boolean logic. So that is as a honor to the person who contributed to this area, one of the person who contributed to this area, George Boole. Right. So then just people call it Boolean logic. Okay. So there are some words like Boolean logic. So English logician called George Boole. Venn diagram. Venn is another English logician, mathematician. Okay. De Morgan rule. De Morgan is another English mathematician. Right. De Morgan, Boole, Boolean, Venn. So they are all English mathematicians. And no wonder how English dominated the world. Right. So the main reason English dominated the world is, right? Yes, there scientists are there, but more than that, the logicians, Boole, Venn, De Morgan. So that is why the computer is predominantly English people's toy. Right? English people, British, American. Okay. So their logical thinking is for some reason higher than rest of the people. In general, the Western Europe, but for some reason, the English people came up with these, or at least they formalized these concepts. Right? Especially the logic field was formalized by these English logicians, right? Boole, Venn, De Morgan, and so on. Right. So what is a proposition? Proposition is a statement which is either true or it is false. For example, when I say 5 plus 2 is 7, so we all know that 5 plus 2 is 7. Right? So that is a proposition. So do you have any doubt about that? That 5 plus 2 can be 8. Sometimes 5 plus 2 can be 10. Do you have any such a thing? So, and again, this is for intellectuals. Right? This is not for crooks. අපි කියන්නේ කට්ටයෝ ඉන්නවා කියලා. කට්ටේට කියන්න පුළුවන් 5යි 2යි 7යි නෙමෙයි 5යි 2යි තව එකක් කියලා. එයාට කියන්න පුළුවන් නෑ මම හිතුවා මේක 8යි පාදයෙන් කියලා. So of course when I say 5 plus 2 is 7, I am a human on earth. So we use base 10. එහෙනම් මම කියන 8 පාදෙන් කියලා. මං කිව්වේ නෑ 8 පාදෙන් කියලා. එතකොට ඔයා හිතන්න ඕනේ මේ මම මිනිසෙක් විදිහට මම සාමාන්‍ය මිනිසෙක්. සාමාන්‍ය මිනිස්සු 10 පාදෙන් තමයි කතා කරන්නේ. ඔබ දැකලා ඇතිනේ සමහර වාහනේ මෙහෙම question තියෙන්නේ. 1 plus 1. Is it 2? Is it 1 0? Is it 3? ඔහොම අහනවනේ ඒක පොඩි ඉස්කෝලේ යන පොඩි ඔය වගේ කතන්දර කියලා හරියට ජොලි කරන්නේ. So someone will say okay 1 plus 1 is 2 because if it is base 10. 1 plus 1 is 1 0 if it is base 2. ඉතින් මම කිව්වේ නෑනේ base 2 කියලා. තව එකක 1 1 එකතු වුනම 3 දෙනෙක් වෙනවා අර husband and wife එකතු වෙලා දැන් පවුලේ 3 දෙනෙක් කරා. හරි ඉතින් එහෙම කිව්වේ නෑනේ අපි. අපි කිව්වේ 1 plus 1 කියලා සාමාන්‍ය ලෝකේ ගණන්. හරි එහෙනම් කියන්න ඕන context එක. Yes, according to the context of base 2 numbers, yes, then 1 plus plus is 1 0. Okay. So therefore, unless we specifically mention, so we use the normal context. Right? We use the normal context. Okay. Right. So therefore, 5 plus 2 is 7 is a proposition because it's true. Right? It is true. So sun rises in the west. It's a proposition because it's west. It is false. Or second is taken. So then someone will say, okay, the concept of the මෙහෙම කාට කියන්න පුළුවන් නේද? Concept of east west is relative concept. එහෙම කාටද කියන්න පුළුවන් නේද? How do you prove that it is west? So do you have an answer for that? Do you have an answer for that? So that is not a problem. Yes. East, west, north, south is relative concept. So according to that, our standard, that is west. So therefore, it has no issue. So basically, we look at from where the sun rises and we call it east. Right? So that is how you make it. Yes, it is relative, but according to our standard, this statement is correct. 5 is an even number. It's a proposition because that is false. Because we have a definition. A number divisible by 2, those are even. Number not divisible by 2, those are odd. So therefore, according to our definition standard, yes, this is a proposition. There's no doubt about it. Okay. So these are some examples of not propositions because don't apply Boolean logic to anything other than propositions. So this is not a proposition. Why? Is 5 plus 2 equals 7? This is not a statement. This is you asking a question. So when you're asking question from me, I can't say it is true or false. So I have to give an answer for that. So therefore, your statement is not a proposition. So therefore, I'm not going to apply Boolean logic to this kind of a statement like is 5 plus 2 equals 7? Is London the capital of England? No. So it's not relevant. So we are not going to use Boolean logic to process that kind of questions. So if someone says something like this, X is an odd number. So then we can't say it's a proposition because we don't know what is your X is. If your X is 2, that is false. If X is 5, that is true. So therefore it can be true or false. Without giving what is your X value is, it is not a proposition. Right? For real numbers, X is greater than Y. Say assume X and Y are real numbers. Someone will say X is greater than Y. No, that is not a proposition. For example, if you take X as 5 and Y as 10, that is false. But if you take X as 10 and Y as 3, that is true. So therefore, without knowing what is your X and Y value, this is not a proposition. Because it can be true, it can be false for different scenarios. Right, so next one, can you tell me whether this is a proposition or not? So X is a member of real number. Okay, X is a real number. X squared is greater than 0. Right, so this is my statement. X is a real number. X squared is greater than 0. Is it a proposition or not? I just need an answer true or false, yes or not. That's all. Don't give me any explanations or nothing. Yes, no, or neither, or something else. Okay. I give you 3. Yes, no, else. So this is my statement. X is a real number. For all x which are real numbers, x squared is greater than 0. What is your answer? Yes, no, something else. Something else. You don't have to tell me what is your something else. So that means you don't get into any of these categories. Right. So the simple answer is all of you guys are wrong. We can කලබලේනේ. කලබලේ රැල්ලට යනවා. ඔකට තමයි රැලි හදන්නේ දේශපාලන. රැල්ලට යනකොට අනිත් එකත් මොකද කරන්නේ? කරේ නගිනවා. ආයි කල්පනා කරලා බලන්න. So my question is it a proposition? So first of all, you must know what are real numbers. අපි real numbers මොනවද කියලා කතා කරන්නේ පළවෙනි දවස්. What are the numbers කියන්නේ? The natural numbers, integers, rational numbers, irrational numbers, real numbers කියලා කතා කරන්නේ. Some special cases, what is mean by negative, what is mean by nothing or zero, what is mean by infinity. So කතා කරේ හේතුවක් ඇතුව. Yes, so the final answer is the correct one. This is not a proposition. The answer is no, because this statement can be true, yes, for many situations, but there's one situation, there's one real number, this statement is false. That is when x is 0. 0 is a real number. So when x is 0, 0 squared is 0. Can you say that 0 is greater than 0? No, 0 is not greater than 0. 0 is equal to 0. So therefore, this is not going to be true for all real numbers. So that means it is true in some cases, false in some other cases. At least one case it is false. So then how do you say that it's a proposition? So this is not a proposition. But if I say x squared greater than or equal to 0, that is a proposition. That is a proposition. Okay. So now it's a proposition, but earlier it was not a proposition. So when you answer this kind of a statement, you need to look at all possibilities. ඒක හදිස්සි වෙන්න එපා කියන්නේ. හරි. කණෙන් රිංගනවා කට්ටිය. හරි. කණෙන් රිංගලා යනවා කට්ටිය. Right. Opinions are not propositions. Because opinions are your opinion. ඒවත් එක ආගු කරන්න කියලා තේරුම් නැහැ. Opinions එක ආගු කරන්න යන්න එපා. හරි. කවුරු හරි කිය අරය හරි ලස්සනයි කියලා. තව කවුරු හරි කිය අනේ යා හරි කැතයි කියලා. හරි. ඉතින් ඔයාට ලස්සනයි අරයට කැතයි. Who cares? So you know that in Sri Lanka, so there are some funny events. After that, there are a lot of arguments, sometimes fights. Right. Beauty pageants. Right. Miss Sri Lanka තෝරුවට පස්සේ ඔන්න වලි. අර UK ඇමරිකාවේ දෙක දවසක් මම දැක්කා අර හෝටලේ මරා ගන්න. නේද? හොඳම සාහිත්‍ය පොත තේරුවට පස්සේ වලි. ඒ පොත නෙමෙයි හොඳ මේක අනිත් පොත. මෝඩයක්කෝ. සාහිත්‍යය ඉතින් එහෙම තමයි. ඔයාට හොඳ නැති එක අරයට හොඳයි. So those are opinions. So don't consider opinions as propositions. So opinions are opinions. So let's get out of that. So let's get into that kind of a situation, because it's useless argument. Okay. Because there's no definition saying what is beauty is. Right? There's no such definition saying this is what is mean by beautiful. Maybe using some statistics and so on, maybe you can come up with some arguments, but you are getting into some fuzzy areas then. Okay. So that is that is a interesting area for researchers and of course artificial intelligence and so on, but not in Boolean logic. Not in Boolean logic. Okay. Right. So let's do this as exercise. Which of the following are propositions? First one. What do you say? Yes or no? Or neither? Or just say proposition or not? Yes or no? Then බය මුකුත් නොකියන අද කලබල නැතුව කියන්න කමන ඉස්සර කලබල නෑ රැල්ලට ගියා. That is not a proposition. Right? That is not a proposition because it depends on the x value. Right? For example, if x is 2, 2 is greater than 5 is false. But if x is 10, 10 is greater than 5 is true. Therefore, it's not a proposition. Okay. What about the second one? Of course, second one we already done. So that is a proposition. Because for any real number, when you square it, it is greater than or equal to 0. So what about the third one? What about the third? Gold is the capital of Sri Lanka. So that is a proposition. Why? Gold is not the capital of Sri Lanka. Right? So do you have any doubt about it? What is doubt on the gold? Commercial capital administrative capital. So therefore, that is true. That is false. So false statements are propositions. Remember, if a statement is false, it's a proposition. So what about this one? If x is a positive even number, then x plus 2 is also an even number. Is it a proposition or not? Yes, it's a proposition. For any positive even number, this is correct. If you take that even number as 4, 4 plus 2, 6, 6 is also even number. So you can see that for any positive number, this is correct. So therefore, if it is correct for all the scenarios, that is a proposition. Right. Final one. iOS is better than Android. That is not a proposition because it's opinion. One person will say iOS is better. Another person will say no, Android is better. Due to usability, availability of applications and so on. Okay. Other person will say iOS is posh, right? It is solid. Its camera quality is better. Yes. Maybe other guy will say no, you don't. I want to find better applications, ease of use, right? And so on. Right. So there are two types of propositions. Now we are into the subject, our computer subject, okay? After understanding these things. So we can categorize propositions into atomic propositions and composite propositions. Right? Or compound or composite propositions. Atomic proposition means that it's a proposition and we cannot subdivide it into smaller propositions. Right? We cannot subdivide it into smaller propositions. So then it's atomic proposition. Like 5 plus 2 is 8. 10 is odd number. Atomic propositions. But there are propositions which are not atomic. Something like this statement. 5 plus 2 is 7 and 5 is an odd number. So why do we call that this is proposition? Because this statement is 5 plus 2 is 7 is true and 5 is odd number is true, true and true is true. So therefore this statement is true. If a statement is true, it's a proposition. If the statement is false, it's a proposition. So therefore this is a proposition. But we can clearly subdivide this into these two sub-propositions. 5 plus 2 is 7 is a proposition. True. 5 is an odd number is a proposition. So therefore inside this big proposition, there are two small propositions. So therefore this statement is a proposition, but it is a composite or compound proposition. Okay. So this is another compound proposition. Paris is the capital of France. Yes, true. Or France is not a member of European Union. So that is false. So true or false is true. Something is true or something is false, it's a proposition. So therefore this is a big proposition. But this proposition has two small propositions. So this compound proposition consists of two atomic propositions. Okay, two atomic propositions. So now you must know what is atomic proposition, what is a compound proposition. Any question? Right. So now our next topic is Boolean logic operators. The parachute taking Boolean logic operators are dependent on. So why are we interested in Boolean logic operators and or not XO? Because it is Boolean logic operators that combine other propositions into compound propositions. Boolean logic operators දැන් මොකද මේ propositions එකතු කර කර combine කර කර වෙන proposition හදන්න පුළුවන්. So that is why we are interested in Boolean logic operators. So that is ඕක තමයි අපි මිනිස්සුත් එක්ක කතා බහ කරනකොට logic build කරද්දි කරන්නේ. හරි. මිනිහට මගෙත් එක්ක පොඩි තරහකුත් තියුණා. හරි. මිනිහට පොඩි අවස්ථාවකුත් හම්බුණා. මිනිහත් දන්නේ නැහැ ඔක් කරේ. කියනව නේද එහෙම? හරි. Proposition දෙක තුනක් එකතු කරලා කතන්දරයක් build කරනවා. Argument එකක් build කරනවා. So that is called argument. Actually, that is not argument. That is sort of a compound proposition. Right. So therefore, we are interested in logic operators. So very specifically, Boolean logic operators, because by combining propositions using Boolean logic operators, we can create new propositions. Right? New propositions. But when you combine, you must use Boolean logic operators. Otherwise, the result is not a proposition. You can't say 5 is even number, subtract 5 plus 2 is 8. So it doesn't make any sense. ඉලක්කම් එක්ක එකතු කරනවා අඩු කරනවා වැඩි කරනවා බෙදනවා කරනවා වගේ propositions එක්ක අපි කරන්නේ මොනවාද? Not and or XO. වෙන දේවල් කරලා හරියන්නේ නැහැ. ඒ දේවල් එක ඒ දේවල් කරනවා. Right. So there's a connection between Boolean logic and sets. Actually, sets is a very funny subject. Sets is for me, sets is the most important subject in maths. Pulaka. Because sets subject is related to so many other areas, especially for IT students. Sets is related to Boolean logic. Sets is related to probability. Sets is related to relational theory, that is in databases. So therefore, understanding sets is super important to understand so many other areas in maths and computer science. Okay. So once you understand the connection between sets and Boolean logic, you are in a very much better position to understand Boolean logic. So understand Boolean logic is one thing, right? So remember, so when you learn a topic or subject, there are few states you can get into, right? So one situation is you have understood. So that is good. So that means you have understood it. Second one, you have not understood. Right? So you have understood, you have not understood. What is the third situation? Can anyone tell me? So for example, you have learned sets in O-level, right? Now you might be in three possible situations. You have understood sets, you have not understood sets. What is the third situation? Of course, you can say I have understood some concepts, maybe 70% understood, 30% not understood. So that is also valid, right? Again, මම ඒකේ තියෙන සමහර concept තේරුම් ගන්න තියෙනවා, සමහර concept ගැන මට සැක තියෙනවා. Okay. Right. Anyway, that is, let's say that is another situation. Or maybe 20 to 80, or maybe 30 to 70. 30 understood, 70 not understood, or maybe 80 understood, 20 not understood. That is also fine. So can you get into another situation? These are the interesting questions you must ask from yourself. ඔය අතර ඔයා වැටෙන්න පුළුවන් තව සිටුේෂන් එකක් තියෙනවා. එහෙම බලන්න. ඔගොල්ලෝ ස්ටඩි කරනවා කියලා කරනවා නේද? ගෙදර ඉන්නකොට සමහර මාත් අපේ අම්මා තාත්තා නම් මට ජීවිතේට එක දවසක්වත් ස්ටඩි පාඩම් කරන්න කියලා නෑ. විභාග පාස් වෙන්න කියලාත් නෑ. හරි? මට මොනවා වෙන්න ඕනද කියලා මට කවදාවත් කියලා නෑ. ඉංජිනේරු උපයන් කියලාත් නෑ, දොස්තර කෙනෙක් වෙයන් කියලාත් නෑ. නිකන් හින්ට් එකක්වත් දීලා නෑ. උඹ වෙයන්. උඹට ඕන එකෙක් උඹ වෙයන්. කන්න බොන්න දෙන්නම් අවුරුදු 19ක් 20ක් වෙනකන්. අපිනේ හැදුවේ. හැබැයි ඊට පස්සේ අපේ යැපෙන්නේ එපා ඔච්චරයි. අපේ වාක්‍යෙම ඉවරයි. සමහරලාට ඕගලන්ට ඒ වගේ සුන්දර අත්දැකීමක් ලැබුණ නැතුව දන්නේ නැහැ. මට කියන්න අනිත් සිටුේෂන්ස් මොනවද ඔයා වැටෙන්න පුළුවන්. So you have understood it, you have not understood it, maybe 20, 80, 30, 80, but you know that 30% understood, 70% not understood. But you know that. What are the other possibilities? I don't want to understand. So that is a very interesting answer. Actually, that is not something I expected. Okay. Right. So maybe that guy will say, I don't want to understand this. So that is a very interesting answer. එතකොට කාටද කියන්න පුළුවන්? ඔය පොඩි උන් එහෙම ඉන්න හරි. පොඩි කාට අම්මලා තාත්තලා මේ සමහරට ගහනවා ඉගෙන ගනි කියලා. මම දැකලා තියෙනවා. පව්. පොඩි එකාගේ යටිහිත කියනවාද? මට මේක තේරුම් ගන්න ඕනේ නැහැ. මම ආස නැහැ ඒකට තේරුම් ගන්න. මම ආස වෙන දේවල්. මම ආසයි චිත්‍රයක් අඳින්න. ගිටාර එක ප්ලේ කරන්න. So that is correct, right? That is correct. So that guy will say, no, I don't want to understand this. But anyway, again, we can put it into that category, right? So again, what තේරුම් ගන්න ඕනේ නැහැ කියනවාද? මම මේක තේරුම් අරන් නැහැ. තේරුම් ගන්න ඕනෙත් නැහැ. But anyway, ultimately that guy knows that, at least that guy knows that that guy is in this category, not understood. ඒක නේ again තේරුම් ගන්න ඕනේ නැහැ. But therefore, we can put that guy also into that category. And that guy knows that he or she has not understood, but at the same time, he or she will say, okay, I don't want to understand this also in the future. Because I have better things in the world to do than this. Maybe it is important for you, but it is not important for me. So that is also fine, right? Because every person is different. Can you think of any other situation? Maybe no idea about it. Okay, maybe ගෙදර ඉන්න පූසයෙන් ඇහුවොත් මට නම් මේක understand මොනවද තේරෙන්නේ නැහැ. මට මේ මොන කියන්නේ මොනවද කියලා තේරෙන්නේ නැහැ. ඔය එකත් හරි. එක්තරා විදිහකට. right? මේ යනවා තේරෙනවද නැද්ද කියලා මම මේ තේරෙනවද නැද්ද කියලාවත් දන්නේ නැහැ. කොටින් මේ කියන්නේ මොනවද කියලාවත් තේරෙන්නේ නැහැ කියන්නේ. Right, that is also possible. Now you can see that there are so many possibilities at least, right? So many possibilities. And another possibility is, so you think that you have understood, but in reality you have not understood. So that is the most dangerous situation. ඔයා හිතන් ඉන්නවාට තේරුණා කියලා. නමුත් කවුරුහරි ප්‍රශ්නයක් ඇහුවම සමාජෙට ගියාට පස්සේ ස්මාර්ට් වෙනවාට තේරෙලා නැහැ ඒක. So that ඒගොල්ලෝ තමයි එහෙනම් කයියෝ. කියවන්නේ ලොකුවට. කියවන්නේ ඇයි? දන්නවා කියලා හිතාගෙන. හැබැයි වැඩේ බාර දුන්නට පස්සේ කරගන්න බෑ. මොකද එයා හිතාගෙන ඉඳලා තියෙනවා දන්නවා කියලා. හිතාගෙන ඉඳලා තියෙනවා දන්නවා කියලා. ප්‍රශ්නයක් දුන්නා විභාගයට ගියාම හරි සමාජයට ගියාට පස්සේ ඔන්න දැන් ඒක පාවිච්චි කරගන්න බෑ. නැත්නම් ඇත්තටම එයා හිතාගෙන හිටියට එයා දන්නේ නැහැ ඇත්තට කතන්දර. එයා බොරු තමයි ඇත්ත කියලා හිතාගෙන ඉඳලා තියෙන්නේ. That is another situation. Right? So that is why you need to face exams, quizzes, face interviews, talk. නේද? කට වහගෙන ඉන්න තාක් ඕවා අහුවෙන්නේ නැහැ. කට ඇරියම තමයි අහුවෙන්නේ. දැන් ඕගොල්ලන්ට ප්‍රශ්නයක් අහම උත්තර දෙන අයට තමයි අහුවෙන්නේ. මගේ උත්තරේ හොඳ ටිකක් මදි, ඊට වැඩිය හොඳ උත්තර තියුණා. නැත්නම් මගේ උත්තරේ හරි. ඒ ඔක්කොම අහුවෙන්නේ උත්තරයක් දෙන කෙනෙක්. උත්තරයක් නොදෙන කෙනාට ඒව අහුවෙන්නේ නැහැ නේද? සමහරවිට එයා හිතන් ඉන්නවා මම ඔක්කොම දන්නවා. මම කට වහන් ඉන්නවා. So there are people who think they have understood it, but actually they have not understood it. And they have never checked that also. They have never checked that, double checked much in reasonable manner. So there's another. So these guys are going to get into troubles also. මොකද දන්නවා කියලා හිතන් ඉන්නේ. ඒගොල්ලෝ තමයි ගහ උඩට නැගලිවල බහින්න බැරුව බලන් ඉන්නේ. එන වලවල් වල වැටලා ඉන්නේ. නේද? බිස්නස් කරන්න කියලා බංකොලොත් වෙලා බලන් ඉන්නේ. අයි දන්නවා කියලා හිතාගෙන පටන් ගන්නවා. හැබැයි කරගන්න බෑ. ඇත්ත කතන්දරය එයා දන්නේ නැහැ. So there's another set of people. These guys are the unfortunate guys. මේගොල්ලෝ තමයි අවාසනාවන්ත පව් කට්ටිය. ඒ කවුද? So there are a set of people that actually they have understood it, but they think that they have not understood it. ඔන්න ඔය කට්ටිය තමයි ඇත්තටම පහව. ඔව්. හරි. මේ හොඳට තේරුම් අරන් ඉන්නේ. හැබැයි මිනිහා දන්නේ නැහැ තේරුම් අරන් කියලා. මිනිහා ඇහුවම කියන්නේ අනේ මන් දන්නේ නැහැ, තේරිලා දන්නේ නැහැ. හරි. ඔන්න කවුම සෙට් එක. Right. Why? Because this guy has not evaluate himself or herself. නේද? ඒකේ ප්‍රශ්නයක් කවුරු හරි කතා බහ කළා, ඒ වගේ quiz එකක් කළා, paper එකක් කළා පෙන්නන්නකො. ඔයාලට එනවනම් ලකුණු ටික අවශ්‍ය ප්‍රමාණයට. I am not saying that everyone must be perfect. No one can be perfect. But maybe to a certain level. So there's nothing called I have understood 100%. There's nothing called that. Okay. But at least you are in 80% or above 80%. The unfortunate thing is they have really good understanding, maybe more than 90%, but they think that they have not understood it. Why? They have never ever seriously evaluated themselves. So they lack confidence, self-confidence. Okay. So you can see there are situations like that. Okay. Right. So therefore, it's very important you understand sets and double check whether you have understood sets. Build that confidence about the sets so that you are in a very good position to understand Boolean logic, probability, relational algebra. Right? Remember, probability is one of the key aspects in artificial intelligence, data science. Right? So therefore, take sets very, very seriously. Okay. So you have sets in your semester 2 maths. Unfortunately, it is in semester 2 maths. Okay. So therefore, what we want to do is, we want to do a quick revision on certain topics in sets. Just the minimum required to better understand Boolean logic. Because formally you will learn sets again in semester 2. Of course, you have learned sets in your O level. Okay. So why do you want to learn sets? Because once you understand sets, there's a sort of a one-to-one mapping between sets and Boolean logic. Right? Boolean logic. And remember, logic is not very easy thing to understand. So that is why there are a lot of මේ සමාජයේ සෑහෙන මෝඩ මිනිස්සු ඉන්නේ කියන්නේ. ඇත්ත කතන්දරේ. සමාජයේ බහුතරයක් මෝඩයි. විශේෂ ලංකාවේ සමාජයක. ඇයි ඒ? ලොජික් තේරිලා නැහැ ඒගොල්ලන්ට හරියට. So ලොජික් තේරුම් ගන්න ලේසි විදියක් තමයි sets වලින් ඇතුල් වෙන්නේ. Sets වලින් ඇතුල් වෙන්නේ. So the main reason is sets we can visualize. Logic we can't visualize. So our human brain is really good at understanding pictorial things. පින්තූර විදියට තියෙනවා දකින්න අපිට මොලේ හරිය ආසයි. So remember, computer processor is number friendly thing. So your computer really like to look at everything as set of ones and zeros, even audio, something like a text, of course a number like this, image, right, video, everything your computer like to look at it as set of ones and zeros. Actually, the computer look at everything as set of ones and zeros. But we humans, we hate set of ones and zeros. What we like is set of mal, either geyak, manusek. So what we like is pictures. So our brain is optimized to process pictures, graphical things, visual things. So therefore, unfortunately, logic is not a visual thing. Right? But sets can be visualized like this. This is intersection, this is union, this is complement, and so on. So that is the advantage you get by first understanding sets, and then try to understand when you have a doubt in logic, see whether you can you can use the corresponding sets concepts and get a clue about your logic, Boolean logic. So that is why we want to first do a little bit of a revision in sets and then move on to Boolean logic. So there's a reason for that. Okay. So I'm doing this topic very slowly because this is the subject where you are differentiating from your dog, cat, donkey, or whatever. ඕකෙන් වෙනස් නොවි වෙන අහවල් එකක් කරත් වැඩක් නැහැ නේද? අහවල් එකක් කරත් logical thinking වලට ගියාම අර බල්ලගෙත් ගන්නට වෙනවනේ. Okay. So there's a one-to-one corresponding. Right. So we'll take a small break and then we'll do a taking 15 minutes, quick revision on sets, then we'll continue with logic. Okay. Right. So now it's 2:20. We'll be starting at 2:35. Okay, so let's continue. Right. So what is a set? Okay. So can anyone tell me what is a set? So again, remember this is the most important subject for your life, logic. So therefore, don't take these things lightly. Be very serious when it comes to logic, because this is the most important subject, right? So what is a set? So you must be having the world's best answer for what is set. Don't settle for anything else. So when it comes to logic, give the best, right? So for example, when you were a kid, maybe your parents try to give you the best nutrition, right? So at the same time, so you must be given the best inputs when it comes to logic, because that is what make your thinking correct or wrong. Okay. So what is mean by set? Something similar in same groups is not a serious answer. Okay. So can you come up with, can you make it a little bit more serious? So someone else can make, because at least now we have something starting point, right? So something is better than nothing. Okay. Or can you guys tell me some features of set? What are the features of a set? What are the features of a set? Collections of objects. දැන් මම කඩේට ගිහිල්ලා එනකොට බඩු වගේක් අරන් ආවා. අපි හිතමු මේකේ තියුණා ලුණු තියුණා. හරි. රින්ස පැකට් එකක් තියුණා. Collection of objects. Is it a set? Is it a set? So the reason is you learn sets in ordinary level, right? O level. So that is why your answers are O level. So anyway, that is not wrong, right? So unfortunately, you learn sets in O level when you were kids, right? So therefore, no wonder your answers are ordinary level, because you are giving that ordinary level answer. So that is good enough at O level, ordinary level. But now you have passed your A level and into the degree level. So degree level means we are looking for the serious people, serious set of people who can take more responsibilities. And of course, you need to prove that you have that seriousness and you are good enough to get that degree from University of Colombo. Yes, collection of well-defined objects and elements. Right. So now you can see that things are getting better. Right. So set is collection of objects having following properties. Number one, it must be well defined. For example, if someone says some things, that is not a set. It is not well defined. You can't say three random numbers. So how do you know what are your three random numbers are? So that is not a set. So it must be well defined. Something like integer between 2 and 5. Right? Letters in English alphabet. Well defined. Well defined. Letters or characters in the keyboard. Well defined. If you show a particular keyboard. So number one is a set must be well defined. Very specific. Not vague. Second property is there must not be any duplicate elements. So the same element can't be more than once. So therefore, this is not a set. 3, 2, 3, 5. This is not a set because it has violated this. Same element is twice. So this is definitely not a set. Right? Well defined. No duplicate. Third property is order of the element must not be important. If someone says order is important, that is not a set. So if someone says it is 1, then 2, then 3, that is not a set. If someone says first you need to do semester 2, level 1, then level 2, then level 3, that is not a set. If the order is important, that is not a set. So this is what set is. Right? Set is collection of elements having following three properties: well defined, no duplicates, order must not be important. And of course, those elements can be coming from any domain, any area, maybe numbers, letters, colors, people, things, and so on. We don't mind. As long as these properties are met, it's a set. Okay. Right. So these are some examples. Integer numbers between 1 and 5. Of course, integers between 1 and 5 are 1, 2, 3, 4, 5. Set. Student in our class, let's assume there are 30 students in this session. So if we just specify this is Nimal, Amal, Kamal, blah, blah, blah. Yes, so the same student will not be twice, right? Let's assume same student has not logged in twice using two different names. So then it's a set. So we don't care the order. Vowels in English language, set. Of course, I have written it like order, but order is not important, right? When we say vowel, it's a vowel. So these are not sets. Clearly, you can see here duplicates. This is not a set because it says after level 1, level 2, then level 3, and so on. And this is not a set because it says in ascending order. Ascending order means order is important. Of course, integers from 1 to 5 is 5. But when the moment you say ascending order, that is not a set. That is not a set. Between that, I am not very sure whether it's included or not, that you can refer to. I think it depends on the context, whether you are talking about sets and so on. I'm not very sure about that. Okay. Maybe both are included, maybe those are not. I think when we say between, usually those are included. Okay. I'm not very sure, but if you go by SQL, because in SQL also we use between. I think in SQL, when we say between, those are included. Okay, so let's double check because you have that question. I think definitely in SQL, when we say between, I think those two extremes are also included. So we should have asked that from ChatGPT because it's not a search. It says not those are not included. I don't. ChatGPT says those are not included. I'm not very sure. So what about the SQL? Anyway, this is nothing to do with the logic. This is just a word between. Okay. You can see it says yes in SQL operator includes both bound values. So that is why I told because it depends because it's just an English term, right? So different people can interpret it in different ways. So that is why I told you in SQL usually when we say between the bound values are considered. Okay. It will include the values 1 and 5. So these are called sort of opinionated things, right? Because this is a language. In a language, different people can use the same words in different ways. So that is why I told you that in SQL, those two are considered, but maybe another person will say, no, we don't have to consider. But those are sort of opinionated things. Okay. So anyway, that is a valid question. Right. So therefore, this is not a set because anyway, it says ascending order. Okay. Right. 3 random numbers. So sometimes you may feel like that is very specific, but we don't know the elements. Because when we say random number, it can be anything, right? So anything is not a set. Right. So our next concept is, so we are not going to do comprehensive revision of sets, right? Because sets is a topic in your semester 2. Right? Sets and logic are the two biggest topic in your semester 2 maths. Right? You have only about 5 topics. Out of 5 topics, 2 topics are sets, logic. The big topics. Okay. Because for IT students, computer science students, the most important topic in maths is sets and logic. Because computer is processing everything using logic, Boolean logic. Right. What is mean by universal set? Again, you must be having the world's best answer, at least at the end of this session. Because you must be the world's best logical thinker. Don't settle for anything else. So be the world's best logical thinker. Be the world's best critical thinker. So then a lot of problems are solved. වැඩිම බත් කන එක්කෙනා නේද? වැඩිම බර එක්කෙනා, වැඩිම උස එක්කෙනා, වැඩිම ශක්තිමත් එක්කෙනා හරි කමන්නේ නැහැ වෙන්න. හැබැයි ඔක්කොටම වැඩි වටින දේ තමයි තමන් ජීවිතේට වඩාත්ම ලොජිකල් තින්ක මම වෙන්න ඕන. මේ ලෝකේ හොඳම ලොජිකල් තින්ක මට වඩා ලොජිකල් තින්ක කෙනෙක් නැහැ. මට වඩා ක්‍රිටිකල් තින්ක කෙනෙක් නැහැ. මේ ලෝකේ අඩුවෙම වැරදි කරන මිනිස්සයා වෙන්න පුළුවන්. So then you are a superb human being. නේද? ඉස්කෝල වල එහෙම කියන්නේ නැහැ නේද? ලකුණු ගන්න. එහෙමනේ කියන්නේ. විභාග පාස් වෙන්න. අම්මලා තාත්තලා කිව්වද අඩු ගානේ? හොඳම ක්‍රිටිකල් තින්ක වයන් පුතේ, දුවේ, හොඳම ලොජිකල් තින්ක වයන්, ලෝකේ සාධාරණ මිනිසයා වයන් කියලා. ජීවිතේට හොරකම් කරන්න එපා, ජරාව ගන්න එපා, පගා ගන්න එපා, අනුන්ගේ දේවල් අල්ල ගන්න එපා කියලා කිව්වද? එහෙම කිව්වනම් මරු දෙමව්පිය ඉඳලා තියෙනවා. කිව්වත් නැතත් තමන්ට ඔළුවක් තියෙනවා. කිසි දෙයක් ප්‍රශ්න කරන්න නැතුව විශ්වාස කරන්න එපා පුතේ දුවේ කියලා කිව්වද? එහෙනම් මරු. So what is mean by universal set? So you must have the world's best. ඔයාගේ පිඟානේ තමයි logical thinking සම්බන්ධ හොඳම කැම තියෙන්නේ. Never settle for something, right? 1% low quality. This is dead serious stuff. Okay. So I'm not this serious when we talk about numbers, right? Algebra, trigonometry. Right? I'm not that serious because I'm dead serious when it comes to logic because this is the most critical thing. ඔයාගේ process එක දැන් ඔයාගේ brain surgery එකක් කරනවා වගේ වැඩක් මේ කරන්නේ යා. ඔයාගේ ආමාශය ඇලදිව ඒවයි පොඩි පොඩි හුටපඩ තියුණාට කවන්නේ නැහැ. මොලේ අවුල් වෙන්න බෑ. මොලේ එල්ල කිරි වගේ තියෙනවා. මොකද ඔතනින් තමයි ඔක්කොම වෙන්නේ. ඕක අප්සෙට් ගියොත් ඔක්කොම අප්සෙට්. පිස්සුමයි කෙලින්නේ. Right. So how do you represent the universal set? So this is how you represent the universal set, right? So we say E, usually E, O. So these are some sets. Say set A, set B, set C. Right. So then we say this is our universal set. My question is, what is mean by universal set? සාර්වත්‍රතා කුලකය. මොකද්ද මේ සාර්වත්‍රතා කුලකය කියන්නේ? දැන් මේක දන්නවනම් ටකල් උත්තර දෙන්න. එතකොට මම ආයි මේ වෙලාව කකා ඉන්නේ හරි මමත් හරි ආසයි මේක ඉක්මනට කරලා ඉවරලා නේද? එකට පටන් ගන්න තුනට ඉවර කරන්න පුළුවන් නම් නේද? මමත් හරි ආසයි. මට තුනේ ඉඳලා පොඩ්ඩක් මේ වැහි දවස්වල පොඩි රවුමක් ගහලා එන්න පුළුවන්. If you guys are giving me serious answers, collection of all things. What do you mean by collection of all elements? Is it all the elements in the universe? Is it all the elements that you can see? So now I'm asking from you guys, right? මොකද්ද මේ හැම එලිමන්ට් ඔක්කොම එලිමන්ට්ස් කියන්නේ මොනවාද? දැන් ඔයා අහන්න ඕනේ ඒක තමයි. ඔයාගේ O level හරි ඒ දවස්වල අහන්න බෑනේ. එතකොට ඔයා පොඩිනේ. එතකොට ඔයා පොඩි ළමයෙක්නේ. නේද? පොඩි ළමයින්ට ගුරුවරු කියන ඒවා ප්‍රශ්න කරන්න බෑනේ. ඔයාට එහෙම පෞරුෂයක් නැහැ නේ. ඔයාට මටත් එහෙම පෞරුෂයක් තිබුණේ නැහැ ඒ කාලේ. ගුරු O level පන්ති ඉන්න ගුරුවරයා කියන දේට ඇයි කියලා අහන්නේ. එහෙම කොහොමද වෙන්නේ කියලා අහන්නේ. හැබැයි දැන් එහෙම නැහැ. දැන් ඔයත් වැඩි තියෙන්නේ මාත් වැඩි තියෙන්නේ. ඔයාටත් ඡන්දේ තියෙනවා මටත් ඡන්දේ තියෙනවා. එකම වෙන සමාජයට ඕගොල්ලෝ තාම ගෙදරින් යපෙන්නේ නැති. කට්ටියක්. ඔතන ගෙදරින් යපෙන්නේ නැති කට්ටියකුත් ඉන්නවා දැන්. හරි. So දැන් ඔයාලා අහන ප්‍රශ්නෙට මට ප්‍රශ්න කරන්න පුළුවන් මම කියන්නේ ඔයාලට ප්‍රශ්න කරන්න පුළුවන්. At any time you can question what I said if it is opinionated or something. Or if it is a fact also you can question. So I also have the same response. I also have the same rights, right? එතකොට කියන්න බෑනේ මේ ළමා අපහරණයක් කරා කියලා. මොකද පොඩි ළමයි නෙමෙයි. අනිත් ඒ ළමා අපහරණයක් වෙන්නේ නැහැ නේ මේ බුද්ධිමය සංවාදයක් නෑ. What do you mean by all the things? What do you mean by all the things? දැන් කවුරු කියවනේ all the elements කියලා? මොනවාද මේ all the elements කිව්වේ? කියන්නේ අපේ ගෙදර තියෙන වංගෙඩියත් ඇයිද? ඔයාගේ universal set එක. Again you say all the related sets. So that means all the elements of the related sets. එතකොට මේ එළියෙමුකුත් නැද්ද? Because these have nothing to do with the right. So that means all the related sets means if you have something like this, right? So then this is your universal set. Is this your universal set? Because these are something related to you, right? So universal set means all the elements that we are interested. So all the elements that we are interested. So we are not interested in anything outside that. මොකද අපි කියන්නේ සන්දර්භය කියලා. සන්දර්භය context එක. Right? So all the elements that we are interested, when we say we, it's you, it's me. It depends on our discussion. හරි එහෙම නැතු මේ ලෝකෙටම මෙහෙම මේකමයි යුනිවර්සල් සෙට් එක කියලා යන්නේ නැහැ. ඒක ඩිපෙන්ඩ්ස් වෙනවා ඔයා බලන විදිය මම බලන විදිය අපි දෙන්න ඇග්‍රී වෙච්ච විදිය. අපි දෙන්නට ඇග්‍රී වෙන්න පුළුවන්. That is what universal set is. Okay? Right. So that is what universal set is. So all the elements that we are interested, we are not interested in anything outside that. So that is why we draw a rectangle and mark it as the universal set. That inside it, that's rectangular shape is the universal set. Anything outside that is not in the universal set because we are not interested. Right. So that is what universal set is. Now obviously, all your sets must be inside that. Right? So there can't be situations like this is my universal set and there's another, my other sets are like this. So then of course, how can, if you are interested in this set A, how do you say that, how do you exclude this? Because if you are interested in A, your universal set must be inside, your A set A must be inside universal set. So then someone will ask, so what about this? Maybe we are interested in these things, but those are not related to these three concepts. Maybe those are related to some other concepts. So that is why we are interested in those things. So we have included. So that is why there can be elements outside these sets. Of course, they are outside these sets, but still it is inside our interested context. Still we have interested in these elements. So that is why we put it inside it. Now, do you have any questions about universal set? Universal set එක ගැන මොකක් හරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න. මේ ලෝකේ ගොම් ප්‍රශ්න කියලා જાති නැහැ. හරි? Every question is a valid question. Right? Every question is because you have that doubt you are asking. මේ ලෝකේ ගොම් ප්‍රශ්න කියලා දෙයක් නැහැ. මේ ලෝකේ තියෙනවා ගොම් නිශ්ශබ්දතාවය කියලා දෙයක්. ගොම් නිශ්ශබ්දතාවය. තමන්ගේ තියෙන ගොම් කමට ගුණා බූරුවාසේ කටවාගෙන ඉන්නවා. තේරිච්ච අයත් කටවහගෙන ඉන්නවා නොතේරිච්ච අයත් කටවහගෙන ඉන්නවා. තේරිච්ච අය කටවහගෙන ඉන්න කවන්නේ නැහැ. නොතේරිච්ච එක කටවහගෙන ඉන්නවා කියන්නේ ඒකට කවදාවත් කටක් අරින්න හම්බ වෙන්නේ නැහැ. ප්‍රශ්න තියෙනවා අපි හැමෝටම. So do you have any question about universal set? It doesn't mean that I have answers to all your questions. If I also have doubts, I will say no, I also have doubt about it. Maybe we can discuss it next time. But at least it gives me an opportunity to learn something also. Okay. Yes, you have semester 1, introductory maths. So we have started, right? So for some batches, we have not started yet. No, we have started the introductory maths. For all the batches. We did the introduction to numbers. Right, so that is what universal set is, right? Universal set is our total interested context. Okay. For example, let's say this is a set A. Students following an IT degree at Aurora. So this is one of my interested set. So I have another interested set. Students following a business degree at Aurora. So can you think of a possible universal set? Of course, it is unfair for asking you for a possible universal set because you can only guess it. Because I need to tell you what is my universal set is, what is my interested context. But at least can you guess what can be my possible universal set? Now you can only guess because it is in my mind. But can you at least guess and tell maybe your universal set you are thinking right now is this? මොකද මට ගොම් ප්‍රශ්න අහන්නත් අහන්නේ නේද? මම ඔයාගෙන් අහුවොත් මගේ යුනිවර්සල් සෙට් එක මොකද්ද කියලා. ඔයා කියනවා ගොම් ප්‍රශ්න අහන්නේ ඔයාගේ හිතේ තියෙනවා මම කොහොමද දන්නේ කියලා. ඉතින් මම ගොම් ප්‍රශ්න අහන්න නැතුව ඉන්නත් සෑහෙන උත්සාහ කරනවා. ඒත් ගොම් ප්‍රශ්නයක් આવොත් කියන්න පුළුවන් ඔයාට බය නැතුව මේ ගොම් ප්‍රශ්න අහන්න එපා කියලා. හරි? මට හිතෙනවා නම් ඒක ටිකක් ස්ටුපිඩ් ක්වෙස්චන් එකක් නේද? එහෙම එකපාරට ගොම් කියන්න එපා නිකන් පොඩ්ඩක් සැර අඩු කරලා කියන්න. මම මාත් ඒ සමානට සැර අඩු කරලා තමයි කියන්නේ ඔයගලන්ට. ගොම් නම් ගොම්. Can you tell me a possible universal set that is in my mind? Because you can't tell me exactly unless you can read my mind. Of course, no one can read others' minds. Yeah, maybe possible universal set is students at Aurora. Maybe students following a degree at Aurora. Those are all possible universal sets. Right? Students at Aurora, students following a degree at Aurora. But if you say that is maybe from my point of view, maybe someone else's point of view, it is students following a degree in Sri Lanka. Maybe Department of Education. So maybe their point of view, a possible universal set is students following a degree at Aurora. Or if you just take the Department of Education, maybe students in Sri Lanka. So they will say this is a possible universal set. I don't know. So you can see that universal set is not something, this is the universal set. Of course, once you agree, you can agree saying that this is the universal set, but there are multiple possibilities until you decide. But when you decide it, make sure all your interested elements are included. Okay. So therefore, all your interested sets must be inside that. Now, do you have any doubt about universal set? Any doubt? Anything not clear? Still anything that you feel like fuzzy? So now you must not have any doubt about set. You must not have any doubt about universal set. At the end of logic subject, you must have any doubt about logic. එතකොට ඕන එක කියලා කතා බහ කරන්න පුළුවන් මූණට මූණ බලාගෙන. හැංගෙන්න ඕනේ නැහැ. පස්සේ ගහන්න ඕනේ නැහැ. හරි. ඕන කෙනෙක් එක්ක ජනාධිපති හම්බුණත් මේ රටේ අග්‍රවිනිශ්චකාරයා හම්බුණත් මූණට මූණ බලාගෙන කතා කරන්න ආත්ම ශක්තියක් තියෙනවා. That is the confidence you must get. Right? Go to interviews, face the interviews, get jobs, go anywhere in the world and live like a human, true human. එකේ ආවේ පස්සේ යන්නේ නැතුව වහල්ලු වගේ ජය වේවා ගගා දෙමෝපියන් එවන්නේ නැතුව අහිංසක මිනිස්සුන්ව. Right. So it depends, but we can agree. But you can't just arbitrarily agree. Make sure you take all the interested elements and of course all the interested sets inside that. Okay. Right. So now my next concept is empty set. What is mean by empty set? Can someone tell me what is mean by empty set? So usually we represented by 5, right? This is something you have learned it in O level. But I am not expecting perfect answers because I know that you guys learn it in O level as a kid. So therefore, I am not expecting perfect answers, but I expect at least some starting point. So what is mean by empty set or null set? අභිශුන්‍ය කුලකය කියලා ඔයගොල්ලන්ට ඉගෙන ගන්න තමයි මම දන්නේ දැන් කියන්නේ කොහොමද කියලා නා. No representation in the given context. That is not very clear for me. What do you mean by null? Because what I'm asking is what is null set? What is null set? Come null කියලා හරියන්නේ නැහැ. ටිකක් වෙන වචන වලින් explain කරන්න. Set which do not have elements. A set that doesn't contains any value. Any value. Okay. I mean, I hope you mean what you mean by value is element. Okay. Right. So empty set or null set is a set having no value, no elements. No elements. So that means I can tell a story. So far I have been telling stories, right? Vowels in English, numbers between 1 and 5, students in this class. So I can tell a story which is well defined, but when you analyze the story, you must find that there are no elements. So then it's empty set. Simple as that. For example, right now, if I say students in this session, you know that it is not empty set. Because I think there are at least about 28-30 students in this session. So definitely it is not empty set. That you can understand. But maybe after 6 o'clock, still let's say session is valid. Maybe even I have log out. So then most probably the students in this particular Zoom session will be an empty set. Still I can say students in this Zoom session at 6 p.m. So most probably that will be empty set. Most probably no one is in that session. කවුරුත් නිින්ද ගිය කෙනෙක් ඉන්නවනම් තාම Zoom session එකේ දාලා මිනිහා නිදිත් දන්නේ නැහැ. ඒක වෙනම කතාවක්. එහෙම නැහැ කියමු. So then it's most probably empty set. So that is empty set. Example of empty set. Or I can tell you a story, but when you analyze it, there are no elements like negative numbers between 2 and 10. Okay. So it's a story, but there are no negative numbers between 2 and 10. So therefore it's an empty set. But if I say negative number between -2 and -10 or -2 and 10, that is not empty set. Right. So do you have any doubt about empty set? Or do you feel like you have the world's best definition for empty set? මං කියන්නේ ඔයා තමයි මේ ලෝකේ රහමතේ ඒක හදන්න ඕන. ඔයා ගාව තියෙන සම්පත් වලින් නැති සම්පත් වලින් ඔයා හොඳම දේ කරන්න හදන්න ඕනේ. හොඳම කිරියොත් දාන්න ඕන. අමාරු වැඩ නෙමෙයි. නැත්නම් Tamanට පුළුවන් උපරිමේ කරන්න ඕන හැමදෙස්සෙම. Tamanට පුළුවන් උපරිමේ. Tamanට හදන්න පුළුවන් හොඳ මේක හදලා දෙන්න ඕන. Tamanට දෙන්න පුළුවන් හොඳම දේ දෙන්න ඕන ලෝකෙට. ඒක ලෝකේ හොඳම දේ නම් තවත් හොඳයි. ඒක ලෝක කොච්චර සුන්දරද? ඒක කොච්චර ලස්සනද? වාහනයක් අරන් පාට බයිනකොට හැමෝම මේ ලෝකේ ඉන්න හොඳම ඩ්‍රයිවර් වෙනවා නම් හෙට උදේට පාට බැසම පාර යනකොට කොච්චර සතුටක් දැනෙන්නේ මිනිස්සුන්ට. එහෙන් දානවා මෙහෙන් දානවා. එයා හන්දිය දාපු සිග්නල් එක මේ හන්දියට ගිහන් තියන් ඉන්න කාලකන්ණි එකෙක්වත් නැහැ නේද පාරේනේ. හැමෝම මේ හිතනවා. මේ හිතන්නේ නැහැ නේ. මේ හිතන්න බෑ මොකටද? හරි. මේ හිතන්න හැමෝටම බෑ. එක්කෙනෙක් දෙන්නෙක් හිතුවා කියලා ලෝකෙ සුන්දර වෙන්නේ නැහැ. අඩු ගානේ බහුතරේවත් එහෙම හිතන්න ඕන. ඒකනේ මිනිස්සු ඒ වගේ මිනිස්සු ඉන්න රටවල් වලට යන්නේ මයිග්‍රේට් වෙලා මේක හදාගන්න බෑ කියලා නේද? ඩිසිප්ලින් එකට වාහන එලවන, ඩිසිප්ලින් එකේ තමන් ජීවත් වෙන, ජරාව කන්නේ නැති, එක එකාගේ පස්සේ යන්නේ නැති මිනිස්සු ජීවත් වෙන රටවල් වලට යන්නේ ඒකනේ මේක හදනවට වැඩි දෙසි. ඒ වගේ තැනකට යන්නේ කියන්නේ. Right. So now you must know what is a set, what is universal set, what is empty set. So now we are moving to the set operations. Okay. So what are the set operations? Can someone tell me what are the set operations? So this is not a set operator. What is in your screen is not a set operator. That is a logic operator. Can someone tell me what are the set operators? And set එක සෙල්ලම් කරද්දී පාවිච්චි කරපු දේවල් මොනවාද? What are the arithmetic operators? Add, subtract, multiply, divide. ඔය හතරෙන් තමයි සෙල්ලම් කරේ නම්බරත් එක්ක. set එක සෙල්ලම් කරන්නේ කොහොමද? set එක සෙල්ලම් කරන්නේ operators මොනවාද? Anyone? Yes, union, intersection, complement, right? So those are the operators. You play with sets, right? Union, intersection, complement. ඡේදනය, මේලය, අන්දන අනිත් එක කියන අනුපූරකයද කොහෙද නේද? Right. So what is mean by intersection? Can someone tell me what is mean by A intersection B? I am not asking difficult question. Just give me බොහොම අහිංසක සරල හැබැයි හොඳම උත්තරේ දෙන්න බලන්න ඔයාගාව තියෙන. සරලම, කෙටිම, පැහැදිලිම, අදාළම උත්තරේ දෙන්න බලන්න. Simple, short, clear, relevant. අදාළ නැති බයිලා ගහන්න බෑ. කෙටියෙන් කියන්න ඕන. සරලව කියන්න ඕන. දැන් එහෙම ගමු මුකුත් නොකිය ඉන්න එපා හරි. ඔයාට පුළුවන් හොඳ මේක දෙන්න. What is mean by intersection of set A and B? Element that both have. The section that belong to both A and B. Connection between A and B. Connection between A and B. Okay. මම හිතනවා හිතන විදියට අනුව ඒකත් හරි. මොකද හිතන විදිය සමහරට connection එකක් කියන්නේ හරි කැපිටල් තැන වෙන්නේ නැති. හරි. Right. Common elements for two or more sets. Okay. So all these answers are reasonable. At least now I am a little bit happy. Right? Not little bit happy. I'm really happy about those answers. එකක් තමයි ඕගොල්ලන්ගේ වචන වලින් උත්තරේ දුන්නා. මම දන්නවා ඕගොල්ලෝ මේ කොහෙන්වත් copy paste කරලා දුන්න උත්තර නෙමෙයි කියලා. ඒකන් තමයි උත්තර perfect නැත්තේ. හරි. සමහරවිට පුළුවන් මේක chat GPT ට හරි කාට හරි දීලා Google search කරලා දාන්න. මම දන්නවා මේ එහෙම උත්තර නෙමෙයි මෙතන බහුතරයක් තියුනේ. තමන්ගේ වචන වලින් කතා කරනවා. So that is good. Right? But at the same time those are really serious answers. Right? Serious answers. So that is what we need. So A intersection B means when we have two sets, now you know what is a set is, okay? So intersection is the common elements. Elements belong to both set A and set B. Or you can say common elements. If this has something like 1, 2, 3, 5, and if B set has 6, 3, 9, so 3 is in the intersection. P or anything that belong to both A and B is intersection. Intersection is belong to A and belong to B. Right. Now, can someone tell me what is union? What is mean by A union B? A union B. ඒවා දන්නේම නැතුව චුට්ටක් වෙලා ඉනකොට අපි ඉන්නේ ලොජික් වල තමයි යා. චුට්ටක් වෙලා ඉනකොට තේරෙයි දැන් අපි ඉන්නේ සෙට්ස් වල නෙමෙයි ලොජික් වල කියලා. All elements A and B. All elements. All elements in both A and B. All elements in A and B. Right. So don't give me any other answers. Okay. All elements A and B. The answer දෙපා කොහොමද දැන් එනවා සමන් පරණ answers එනවා ඇති. හරි. පොඩ්ඩක් හෝ. හරි පොඩ්ඩක් හෝ. Right. All elements in A and B. ඒ කියන්නේ elements A ගෙත් ඉන්න ඕනේ B ගෙත් ඉන්න ඕනේ A and B. The all elements, so if this is 3, 2, 4, 5, right, 6, 8, all elements A and B are 4 and 5. All elements A and B. That is 4 and 5. So that is your union. Is that your union? දැන් ඔයගොල්ලෝ කියන්නේ ඒක නේද? මම ආයි කියලා බලන්න මට තේරෙන්නේ නැත්නම් නැනේ. All elements A and B. A and B. All elements A and B 4, 5. Elements common in both sets. Common in both sets are 4 and 5. Right? මම අන්තිම එකට උත්තේ elements common in both A and B. All elements in both sets. Both sets වල ඉන්න elements ගන්නලු. Both sets වල ඉන්න 4 and 5. All elements in A and B. All elements in both A and B. All elements in both A and B. ඉතින් all elements in both A and B කියන්නේ 4 and 5 නේ. එක්ක මට පිස්සු එක්ක are you mad or am I mad? All elements A and B is 4, 5. That is how AND logic work. What is mean by AND? AND කියන එකේ තේරුම මොකක්ද? ඔය හැම උත්තරයකම තියෙන and කියලා. මම මේක බැලුවා AND නැති එක උත්තරයක් කර තියනවා කියලා. AND කියන එකේ තේරුම මොකක්ද? Can someone tell me what is the meaning of AND? ඔයාලට කිව්වොත් එහෙම. You must pass O level and A level. ඒක තේරුම මොකක්ද? O level pass වෙනවා A level pass වෙනවා. You must have credit for maths and science. ඒක තේරුම මොකක්ද? ඕගොල්ලෝ පාවිච්චි කරේ AND. එතකොට maths විතර pass වෙච්ච කෙනෙක් හොයන්න පුළුවන්ද? බෑනේ. ඔයා කියන්නේ and all elements in A and B. With A and B දෙකේම ඉන්නේ මේක දෙන්න. So according to my question is what is A union B? So you guys are telling A and B, A and B, A and B, A and B. ඒ කියන්නේ maths and science වගේ තමයි. පානුයි පරිප්පුයි. bread and butter. bread and butter එක්කොට පස්සේ butter විතර කරන් යන්න බෑ. ඒකයි මම අහන්නේ එක්ක ඔයාට පිස්සුද එක්ක මට පිස්සුද? එක්ක ඔයාට පස්සේ ඉංග්‍රීසි තේරෙන්නේ නැත්නම් මට ඉංග්‍රීසි තේරෙන්නේ නැහැ. Because and means both. Okay. දැන් ඔයාලට මෙතන තියෙන අවුල මොකද්ද? ඔන්න දැන් ඕ කියනවා. දැන් ඕ කියනවා. ඔන්න දැන් කියනවා AOB ලු හොරා වගේ. හොර පූස වගේ. දැන් ඔයගලට තේරෙනවද ලොකු නඩුවක් වැටුනොත් එහෙම ඔයා යන්නේ නැතුව ලෝය කෙනෙක් යවන්නේ නැහැ කියලා. දැන් තේරෙනව නේද? නඩුවක් වැටුණාට පස්සේ කූඩුවට නගින්නේ ඒකට හේතු දෙකක් තියෙනවා. හරි. එකක් තමයි ලෝයර් නැග්ගේ නැත්නම් එහෙනම් ඔයාට නඩුකාරයා එන ගහන්න දඩ ගන්නවා. ඒක ලංකාවේ තියෙන නීතිය. ඔයාලා දන්නවද අපිට ට්‍රැෆික් වයලේට් කරා කියමු. ට්‍රැෆික් වයලේට් කරාම දැන් අපි හිතමු මගේ අති කහයි මේ ඩබල් ලියර කැපුණා. ඒතර කියන හරි ඔයා උසාවි දානවා. හරි මං කියන උසාවි දානවා. දැන් මගේ වැරද්දක් වුණා නේද අපෝ. වැරද්දක් වුණාම පගාව දෙන්න බෑනේ. මිනිස්සෙක් විදිහට මං සතෙක් නෙමෙයි තිරිසනෙක් නෙමෙයි. අර කෝට් එක දාගෙන ඉන්න එක තිරිසනෙක් වෙන්න එපායි. පගාව ඉල්ලනවනේ. හරි එක්ක ඔයාට කියන්න පුළුවන් හරි ඔයා වැරද්දක් කරේ මම ඔයාට සාධාරණයක් ඉෂ්ට කළා. ඔයාට මං දඩයක් ලියලා දෙන්නම් කියලා ඒක අවුලක් නැහැ. හැබැයි එයාට බෑනේ පගාව ඉල්ලන්න. මොකද එයා තිරිසනෙක් නෙමෙයි මම තිරිසනෙක් නෙමෙයි. ඒතර කියනවා හරි එහෙනම් උසාවි දානවා. ලොකු වැරද්දක් කරේ. හරි ඔයා කහිර කපාගෙන ගියා. that is very big offense. නැත්නම් රතු දාලා තියෙද්දි ගියා. එහෙම දඩ ගහලා බෑ. ඔයා උසාවි දාන්න. ඉතින් මම උසාවි යන්න. මට කියන්නේ මට වෙන කරන්න දෙයක් නැහැ නේ. මම වැරද්දක් කරා. මොකද උසාවි ගියාම මම විලුම් ගස්සවන්නේ නැහැ. මං කියනවා මං යන්න. හැබැයි මට පුළුවන් ද කියලා මේ උසාවි කූඩුවට නගින්න. මට පුළුවන් කියලා උසාවි කූඩුවට නගින්න. හැබැයි ගොඩක් වෙලාවට ඔබ 10000 දඩේ ගහනවා නම් හරි නඩුකාරයාට පුළුවන් ඔක තීරණය එක 10000ද 5000ද එහෙම එයාට possibilities තියෙන තැන තියෙනවා. මිනිහා මම කියන්නේ හැම නඩුකාරයම නෙමෙයි ලංකාවේ බහුතරයක් නඩුකාරයෝ උපරිමේ ගන්න. ඇයි ඒ? ඇයි තෝ ලෝයර් නැතුව ආවේ? හරි. ඒක එක හේතුවක් ලෝයර්ස්ලා අරගෙන යන්න. අපි ඇත්ත කතා කරන්නේ බෑ. second reason එක තමයි ඔයා ඇන් කියන්න ඕන දැන ඕ කියන්න ඕන දැන ඇන් කියලා කියනවා. අන්තිමට අහ කියන කුණු කොටවල් නේද? අහ කියන ළමයින්ට ඔයාට උපැන්න දෙන්න වෙනවා. ඒකන්ද ඔයා කරන්න පුළුවන් හොඳ වැඩේ මොකක්ද? විශේෂයෙන් ඔය ඕ කියන එකට ඇන් කියපු සෙට් එකට මොන හරි නඩුවක් වැටුනොත් එහෙම අනිවාර්යෙන් ලෝයර් කෙනෙක් කියවන්න ඔයා නම් යන්න එපා. හරි? ඔයා නම් යන්න එපා. දැන් ඔයාලට තේරෙනවද ලෝයර්ස්ලා ඔච්චර ගණන් ගන්නේයි කියලා? කස්ටමර්ස්ලා ඉන්න ඕන තරම්. එක පැත්තකින් අනිත් පැත්තෙන් එතන හදාගෙන තියෙනවා මේ විදියට. ලෝයර් ආවේ නැත්නම් එහෙම දෙන්නම් බැටේ කියලා. ලෝයර්ත් එක්ක වරෙන් නැත්නම් දෙන්නම් බැටේ කියලා. එතන වෙනම මුදා නොගත් ප්‍රදේශ තියෙනවා ලංකාවේ. හරි ඉස්පිරිතාල මුදා නොගත් ප්‍රදේශ, උසාවි මුදා නොගත් ප්‍රදේශ, වැඩවසම් දේවල්. හැබැයි software engineering, IT field, banking field ඒව මුදාගත් ප්‍රදේශ. තව මුදාගත් නොගත් ප්‍රදේශ තියෙනවා විශ්වවිද්‍යාල ටිකක් තියෙනවා. හරි ඒවට ඇතුළට යන්නවත් බෑ ලේසියෙන් කෙනෙක්ට නේද? නවකවාදයේ දෙනවා. හරි. ඔය තියෙන මුදා නොගත් ප්‍රදේශ. So therefore ඉස්සලා ඔය අනිත් අය මුදා ගන්න කලින් ඔයා මිදිලා ඉන්න ඕන. හරි logical thinker කෙනෙක් වෙන්න ඕන. So the answer is what is mean by union? Belong to A or belong to B. Right? So that is what union. So if it belongs to A, you take it. If it belongs to B, you take it. If it belongs to both, still you take it. So therefore, A union B is 5, 8, 6, say 7, 3. So ඕක කියන්නේ කොහොමද? Belong to A or belong to B. Right? Belong to A or belong to B. නමුත් ඕගොල්ලන්ගේ අර BIT එකේ දාලා තියෙන්නේ කොහොමද? You must have credit for maths and science. එතකොට ඔයාලට කියන්න පුළුවන්ද ඔයාලට දෙකටම තියෙනවා. අවුලක් නැහැ. බෑ maths වලට විතරක් තියලා හරියනවද? බෑ. science වලට විතරක් හරියට තියනවා හරියට. Because it says and. හැබැයි උතන තියෙනවා O කියලා. For example, they say you must have passed A level, of course, with minimum 3 S passes or FIT. අන්න එතන කියලා තියෙන්නේ කොහොමද? O කියලා. So you have A level, you are fine. You have FIT, you are fine. You have passed both A level and FIT. Of course, you are fine. Because it says so. එහෙනම් union කියන්නේ මොකද්ද? Oh. Union එකට and කියන්න එපා. Intersection is and. Intersection is and. Okay? So intersection is and logic. Union is or logic. So when you are supposed to use or, don't use and. That is you are completely messing your logic because A and B is different from A or B. Okay. Right. So basically now you have learned two logic operators. And operator, O operator. So AND operator in logic is same as or similar to intersection in sets. Or there's a connection. Right? If both belong to both only, we take it for the intersection. So therefore in AND logic, if both are true only, result is true, otherwise false. Okay. Similarly in OR operator, right? If at least one is true, it is true. Just at least one, or if both, it doesn't matter. It is similar to union operator. That is, if it belongs to A, or if it belongs to B, it is in the union. Of course, if it belongs to both, it doesn't matter. So you can see that in logic, we say or, in sets, we say union, and therefore in logic, we give the similar symbol also. So this is the sets union. This is or in maths. Okay. symbol logic operator. Similarly, this is intersection and this is AND. Symbol intersection and okay. මේ maths වල හරි පස්සේ අපි ඔකට dot කියලා දෙනවා ඒ ඇවිල්ලා digital logic digital circuits වල ඒ electronic වල plus කියලා දෙනවා union එකට o එකට that is digital circuits. This is maths. Okay. This is maths. So now we have discussed two logic operators with the help of sets. AND operator, AND logic operator, or logic operator. So our third operator is not operator. So what is the corresponding concept in sets? Complement, anupurakaya. Okay. So this is my set A, and this is my A complement. A complement. Okay. So what is mean by A complement? A complement explain කරන්න බෑ. Not belong to A. ඔය පේනවද වචනේ not belong to A and belong to B. Belong to A or belong to B. Not belong to A. Not belong to A is this complement. And of course, we are not interested in anything outside the universal set. That is something we have already decided. So we are not interested in anything else. So therefore, you don't have to mark this because we are not interested. So that is in logic, we say not logic operator, not Boolean logic operator. Okay. And that is true become false, false become true. Because it's not. Say you are poor. So then when you say, I am poor, that is true. But if you say, now remember, you are poor. Let's assume. So now if you say, I am not poor, that is false. If you are poor is true, because you are actually poor. When you say, I am not poor, that is false. Say you are rich. So say you are intelligent. So assume that you are intelligent. Then හරියට එලකිරි වගේ Boolean logic තේරෙනවා සහ සෑහෙන දුරට දැන් වැඩේ හරි. හරි serious ඔය and එකයි ඔය එකයි මාරු වෙලා අතරමං මම්මුලා වෙන්නේ නැහැ. So then you can say I am intelligent. Assume that it is true. Now you go and say I am not intelligent. So that is false. If original statement is true and it's a proposition, the moment you use not, that proposition is now, that compound proposition is false. If original is false, the moment you apply not, it is true. So that is what not operator is doing. So this A is a proposition. If original proposition is true, the not A is false. Original proposition is false, not A is true. Say 5 is greater than 3. True. So then 5 is not greater than 3, that is false. Because 5 is not greater than 3 is false. So understand this. Never be hurry. පොඩ්ඩක්වත් හදිසි වෙන්න එපා logic ඉගෙන ගන්න. Logic නෙමෙයි මොන subject එක ඉගෙන ගන්නත් හදිසි වෙන්න එපා. ඒ හදිසි යන තමයි උදේට ඉස්කෝලේ යනවා හැන්දෑවට පන්ති යනවා. හරි. මොන කරුමයක්ද? ඕගොල්ලෝ නිකමටවත් ඇහුවද? ඉස්කෝලේ ප්‍රින්සිපල් ගෙන් මොන මගුලක්ද උදේට ඉස්කෝලේ යනවා හවසට ටියුෂන් යනවා. එක්ක නේද? එක්ක ගෙදරින් ඇහුවද අම්මගෙන්? මම අහලා තියෙනවා. මම අහලා තියෙනවා. මොන මගුලක්ද උදේට ඉස්කෝලේ යන්න කියන ඇන්දාට ටියුෂන් යන්න කියන. එක මගුලනේ මේ දෙකෙන් උගන්වන්නේ. මම කියලා තියෙන මේ එකක් කොට නවත්තන්න ඕන. එතකොට කියනවා එහෙම කොහොමද ඉස්කෝලේ යන්නේ නැති වුනාම මේ අපිට අහල පහල මිනිස්සු hina වෙයි. ගෙදර ඉන්න එක ඉස්කෝලෙන් එලවලා කියයි. නෑදෑයෝ hina වෙයි. ආයිත් පවුනේ ඉතින් නේද? අපි හදවම අම්මලා තාත්තලානේ. මේ මිනිස්සුන් හිත නරක කරන්න හොඳ නෑනේ. ඉස්කෝලේ යනවා දෙන්නේ නැහැ. හැබැයි දෙකේම එකම උගන්වන්නේ. ඒක හරියට උදේට දත් මදිනවා රැයට දත් මදිනවා වගේද? නැද්ද? රැයට දත් මදින්නේ ආයි දවල් කනකොට සවුත් වෙච්චක් නැහැ. හැබැයි මං උදේට දත් බෙදලා විනාඩි 10කින් ආයි දත් මදින්නේ නැහැ. කෑවොත් විතරක්. හැබැයි ඕගොල්ලෝ තේරෙනව නේද කොච්චර ඉල්ලොජිකල් වැඩද කරලා තියෙන්නේ කියලා. ඕගොල්ලෝ අහලා තියෙනවද වෙන රටවල් වල එහෙම උදේට ඉස්කෝලේ යනවා හවසට ක්ලාස් යනවා කියලා? ජපානයේ ළමයි ඇමරිකාවේ ස්ටුඩන්ට්ස්ලා ඕස්ට්‍රේලියාවේ ස්ටුඩන්ට් ඕස්ට්‍රේලියාවට මෙහෙම පදිංචි වෙච්ච උන් ගිහලා යනවා එහෙම. මොකද ජම්මිට වැඩි පුරුද්ද ලොකුයිනේ. උන් පුළුවන් එහෙ ගිහලා තව ලංකාවක් හදනවා. Because no point doing the same thing twice. Right? No point saying the same thing twice. එකම දේ 10 පාරක් කියන එකේ තේරුමක් තියෙනවද? නේද? අදත් කියනවා හෙටත් කියනවා අනිද්දාත් කියනවා ඉන් අනිද්දාත් කියනවා. What is the point of saying the same thing twice? අද උදේත් ගිහිල්ලා කියපු එක හෙට උදේත් ගිහිල්ලා කියපු. අනිත් උදේත් කියන. එහෙම මොකක් හරි so that is what is meant by critical thinking. ඒතර වෙන රටවල වල ඔයත් උදේ පාන්දර ගිහිල්ලා කියනවාද එහෙම මොකක් හරි? සවුදත් කියනවා අඟහරුවත් කියනවා එකේ පන්තියෙත් කියනවා දෙකේ පන්තියෙත් කියනවා. So think about it. බලන්න මිනිස්සු කොච්චර මඤ්ඤන්ද කියලා. අනිත් මිනිස්සුත් එහෙම මඤ්ඤන්ද කියලාත් බලන්නේ අතරතුර. ලෝකේ ඒක තමයි ලෝකෙට විවෘත වෙලා බලන්න කියන්නේ. ලෝකේ එතකොට අනිත් මේක මෙහි ආයත විතරක් මඤ්ඤන්ද නැත්නම් අනිත් රටවල් වල ආයතත් මඤ්ඤන්ද? හැබැයි ඒක බලන්න පුළුවන් මට ලොජිකල් තින්කින් ඉගෙන ගත්තට පස්සේ තමයි. එතකම් මඤ්ඤම් පේන්නේ සාමාන්‍ය විදියට. Okay. Right. So now we discuss three logic operators: AND operator, OR operator, NOT operator. So our next operator is not a very basic operator, but it's a very important operator. So therefore we take it as another basic operator. So that is called XOR operator, XOR logic operator. Okay. So what is mean by XOR operator? Can you give me example of a XOR operator? Practical use of XOR operator in real world. So I can give you any example of AND operator. Right? මට පාන් සහ පරිප්පු ඕන. ඔන්න AND operator. brush එකක් සහ toothpaste ගේන්න. ඒතකොට දෙකම ගෙනියන්න ඕනේ නේද? brush එක විතරක් අරන් ගිහලා හරියන්නේ නැහැ. trip එකක් ගියාද ඔක්කොම අමතක ගියේ. ඔයා කියනවා අනිවා කඩේට දැන්නේ. මට brush එකක් සහ toothpaste ගේන්න. එතකොට එයා toothpaste විතරක් අරන් එනවද? toothpaste විතර කරගෙන එක්කෝ එයාට logic process එන්නේ. so O කියලා කියනනේ. ඔයාට කියන්න පුළුවන් ඔයා එනකොට කොහොමද කියන්නේ? sunlight කැටයක් හරි O අපිද වෙන මොන හරි මන් දන්නේ නැහැ. හරි බොන්ඩ ලයිට් කැටයක් හරි ගේන්න. නැත්නම් ලක්ස් කැටයක් හරි වෙන මොකක් හරි බේබි සෝප් කැටයක් හරි ගේන්න. O තේ එකක් හරි තේ එකක් හෝ කෝපි එකක් ගේන්න. Now can you give me example of XOR operator? Or what is mean by XOR? So XOR is the real confuser. The reason is when we say O, sometimes we really mean O. But some other times when we say O, what we really mean is XOR. So that is an unfortunate thing in a way, because for AND we have one word, O we have another word, NOT we have another word, but for both O and XOR, we use the word O. that is in not only in English, that is the same in Sinhala, Tamil, and most of the other languages also. Okay. So the reason is humans were not very serious about the difference between O and XO for very good part of the evolution. So the language evolved without a proper word for XO because they were not very serious about the XO logic and the languages evolved. But logicians found that, like Boolean and so on, found that no, O and XO are two different logic. So therefore, we need two different words. Let the language do whatever they want. That is common people. But in logic, let's have different word. So therefore, we have now O gate or the O logic operator, and we have a separate logic operator called XO. So these two are different. So these two are different. So when we say O, it is same as union. So therefore, if it belong to both, still we take it. So that is why if you have both A-level ICT and A-level and FIT, still you are qualified for BIT. Because when they say A-level or FIT, what they really mean is O. Right? What they really mean is O. So therefore, if you have both, it doesn't matter. But when I say bring me, right? Bring me tea or coffee. So then what again? So what I say is O, but what I mean is XO. So I am not expecting you bringing me both tea and coffee. So when I say tea or coffee, what I mean is tea XO coffee. So that is basically something like this. So don't bring me something mixture of tea and coffee or something both tea and coffee. So, but yes, we use the word do, but we don't expect this, right? Make up expect karanga. So when your mother say, right, when your mother says, bring home anchor or Highland. Say packet of milk. Okay. So when she says like that, anchor or Highland, you can bring home anchor. Fine. You can if you bring home Highland milk, fine. What about if you bring both? So your mother will be really upset, right? මුහත් ගොඩඩිය හොඳ හරප්පැටිය කදුව නම් කියන්නේ. ඒතකොට වාට කියන්න පුළුවන්ද අම්මා කිව්වේ ඕ කියන්නේ ඕ ලොජික් කරනෝ දෙකම හරි නේද? ඔව් ටි. නමුත් එතකොට කියයි අම්මා මම දන්න ලොජික් කියන්නේ නෑ. එහෙම තමයි කියන්නේ කියන්නේ. But now you know that what your mother means is XO. So therefore we must be very careful, right? In common communication, when we say O, sometimes we really mean no. Sometimes we really mean XO. We don't expect both to happen. Okay. So that is the difference between O and XO. So, but when it comes to computer, we can't say sometimes we mean no, sometimes we mean XO, right? So therefore, we have two separate symbols, two separate gates later on. But this is called the O gate, and this is called XO gate, because these two logic gates behave completely different manner, different truth tables. So we manufacture O gate separately using transistors. We manufacture XO gate separately. So where XO gate is needed, we fix XO gate. Where O gate is needed, we fix O gate. Okay. So therefore, those two are two different concepts in logic, two different concepts in digital electronic. Okay, so that is very, very important thing for you to understand. Okay. So therefore, what is the truth table of XO? Now, of course, when both true, it is no longer true. Because this is XO. In O, yes, when both true, also true. But in XO, When this is true and this is false, true. When first one is true, second one false, it is true. But all the other cases, it is false. When both are true, also it is false. So that is the difference between O and XO. So therefore, those who are studying logic, right? For us, O and XO are two different concepts. And we know that common people use O for both O and XO, but we are not we are not in the common people's category now. We must be in the category where we know logic. For us, logic is a very serious subject. Okay. Because no point doing critical thinking without knowing these differences. Because then you question everything, but you came up with wrong conclusions. එකයි critical thinking සහ logical thinking කියන දෙකක් කියලා. critical thinking කරනකොට logical thinking දාලා critical thinking කරේ නැත්නම් ආහිර වෙනවා. So this is, if you want to represent it in set notation, of course in sets we don't have a different symbol for that, but you can perfectly consider that it is something like this. Exclusively belong to A or exclusively belong to B. So that is why we say X exclusive, okay? Not both. Okay. Both, that possibility is eliminated in XO. Now we are done with logic operators. So very specifically, we are done with Boolean logic operators. AND operator, O operator, XO operator, and NOT operator. So these are some practical examples, okay? Use of XO. When we say tea or coffee, what we really mean is tea XO coffee. So we don't expect, so I don't expect you to bring me both tea and coffee. Okay. Right. So now we move on to the Boolean algebra. Okay. Boolean algebra. So now the important part is over. Right. So now we are into the regular stuff. So those who have understood up to this point, now you can do the self-study rest of the stuff. Okay, self-study rest of the stuff, because these are just set of rules which you should be able to convince yourself now. If you have understood your logic properly, logic operators, what is proposition, what is logic, what is reasoning, what is formal reasoning, what is formal and scientific reasoning, and blah, blah, blah. Now you are in a position to do the self-studies and finish the logic part, entire thing. Because what you need is a good foundation, good foundation, solid foundation, logical foundation. Okay, right. So anyway, we'll go through the Boolean algebra because that is also required. So Boolean algebra is basically set of rules related to Boolean logic. So just like you have the normal algebra, that is set of rules related to numbers and algebraic expressions. So what are the normal algebraic rules you know? For example, say arithmetic algebraic rules, you know that 5 plus 2 is same as 2 plus 5. So that is a rule that you all know. So do you have any doubt about this? Do you freely use these things? Of course, I have seen you guys do those things, right? So they are similarly, you can say x plus y is same as y plus 6. Assume that x and y are ultimately some numbers. So numbers, you don't do that. But you don't do something like this, right? 5 minus 2 is not the same as 2 minus 5. That එකත් ඔයා දන්න එහෙම නැහැ කියලා. All rules. So those are rules. And you know that x squared minus y squared is x plus y into x minus y. So that is the algebraic rule. The difference of square. Right? තවට මේකෙන් සැකයක් තියෙනවද? සැකයක් තියෙනවා නම් මේක සුළු කරා මේකේනවා. So these are the rules that you have learned, right? So likewise in Boolean algebra also, there are some rules which are correct. So therefore you must know those things so that you can appreciate those rules, and at any time you can use those rules so that you can look at the things in slightly different way. So this is the same thing, you look at this way and that way. And you know that both are the same. So just two representations. So likewise in logic also, when you know the rules, you can look at the same thing in this way, that way, and you know that both are the same. I'm looking at the same thing in two different ways. Okay, right. So what are the Boolean algebraic rules? Sorry that I have a power cut, so therefore I just shifted to the other internet connection. So maybe it is a little bit slow, right? Little bit slow, okay? But I hope you can hear me and see the screen still, okay? Right. So there are 23 rules. Okay. Of course, there are more than 23 rules, but we are only looking at about 23 rules, which are more useful, more relevant to us. And another good news is all these 23 rules have corresponding rules in sets. One-to-one mapping. One-to-one mapping. So if this is a rule in Boolean logic, there's a compatible rule in sets. So that therefore, if you have any doubt about a particular rule in Boolean logic, you can go back to the sets rule and see. So then you will be a little bit more comfortable to understand your Boolean logic rule. And of course, you can use it in the other side also. If you have any doubt about the particular rule in sets, you can get back to the Boolean logic rule and be a little bit more comfortable with that. Okay. So when you can see things in different ways, you are in a better position to understand things. So that is why, because when you know only one thing, you are very narrow-minded. For example, if you know only Sinhala, right? So those are the people they say Sinhala is the best language, right? Sinhale ගාගෙන ඔය ගියේ පහුගිය කාලේ මදාවියෝ සිංහලේ කියලා ගහගෙන සිංහල තමයි ලොකුම ජාතිය. මොකද ඒගොල්ලෝ දන්නේ සිංහල විතරයි. ඒතර සිංහල ලැන්ග්වේජ් එකෙන් තොර ලෝකයක් නැහැ. ගමෙන් පිට වැඩිය ගියේ නැති එක හැමදෙස්සම කියන්නේ මොකද්ද? අපේ ගම තමයි ගම, අපේ පළාත තමයි පළාත, අනිත්‍යව පළාත්ද. මේ මුව පොඩ්ඩක් එහෙම එකයි යන්නේ. පොඩ්ඩක් වන්දනාවක්. එතකොට ඔය කියනවා නවත්තන්න. So likewise, if you know only Boolean logic, so you are again narrow mind. So you must know that there are different type of logics and blah, 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 right? Fuzzy logics are there. And of course, you can compare Boolean logic and sets so that you have some comparisons and so on. Okay, right. So therefore, always freely go for sets and come back to logic, because in semester 2 you have all these things, sets also part of your second semester maths, right? Because they want to give you that opportunity to look at the things in different ways so that you build your confidence. Okay. So what is the one-to-one mapping between logic and sets, Boolean logic and sets? Your AND is intersection. Your O is union. Okay. Your NOT is complement. And not only that, true is universal set, false is empty set. So that is another interesting thing. So when you have true in your Boolean logic expression or some rule, then you have empty set in sets. True in Boolean logic, universal set in set. If you have false in Boolean logic rule, you have 5 sets. Okay, so I just show you one example. Okay, so these are all the rules in one place. Now you can see that this is Boolean logic rule, says this is logic rule, A and B is same as B and A. In sets we say A intersection B is same as B intersection A. In logic we say not of not A is A. In sets we say complement of A is A. So similarly, we have something called De Morgan rule in sets. A intersection B complement is A complement union B complement. In logic, we have not of A and B is not A or not B. So here we have rule in sets A intersection 5 is 5. Of course, that is correct. And logic, we have A and false is false. So we can say 1-to-1 mapping. Right? And here we have not true is false. In sets, we have E complement is 5 because not is complement. True is E, false is 5. Here we have A and not A is false. And here we have A intersection A complement is 5. So, හැම තැනම මේ සම්බන්ධ තියෙනවා. Right? හැම තැනම සම්බන්ධ තියෙනවා. Right? So that is something you must understand first. There's a big connection between sets and logic, Boolean logic. The second thing you want to understand is there's a duality nature, both in Boolean logic and sets. So these rules comes in pairs. මේ rules එන්නේ ජෝඩු එන්නේ. මේවා තමයි intelligent අය උනම් දැනගන්න ඕන. රටා විශ්වයේ තියෙන රටා දැනගන්න. අපේ මිනිස්සු ගොඩනගපු දැනුමේ තියෙන රටා දැනගන්න. Okay. So you can see that this is a pair. This is a pair. This is a pair. දෙක එන්නේ. හරි. දෙක එන්නේ ඔක්කොම. පේනවා. දෙක ඇවිල්ලා තියෙනවා. සමහර ඒවායි අපි එකක් ලියලා තිනවා. ඒකට හේතුව අපි ඒකේ ඩුවල් එක ගැන අපි එතකොට අපිට rules වැඩි නන්ද අපි ඒක එයාගේ ඩුවල් එක මතක තියාගන්න. ඒකයි. So that is why we have only one here. Actually there's a compatible another rule for this one. And similarly for this one. There's a compatible another rule for this one, or dual for this one, a dual for this one. But we haven't written it because the other format we very rarely use. But yes, there's a dual for this, dual for this, dual for this as well. But for this one, you don't have a dual, right? You can see this one, you don't have a dual. The dual තියෙනවා කියලා දැනගෙන විතරක් හරියන්නේ නැහැ. Dual නැති තැන තියෙනවා කියලා දැනගන්න. Right? ඔන්න මෙයාට dual එකක් නැහැ. There's another place where you don't have a dual. That is this one. So this one you don't have a dual. Right? So the reason is the duality nature is applicable. So this is how the duality happens. Your in set level, intersection become union, union become intersection. You can see if you have intersection, that become union, right? If you have a union, that will become intersection. Okay. So if you have a union, that will become intersection. If you have intersection, that will become union. So that is the first change. And if you have if you have E, that become phi. If you have phi, that become E. But rules are E phi. But if you go to the next page, then say this is the dual of this. E become phi, phi become E. E become phi, right? Phi become E. Phi become E. So when you get the dual, intersection become union, union become intersection, E become phi, phi become E. Others are not changed, right? For example, if you have something like complement, in the dual also, complement is the complement. So therefore, usually what happens is you don't get a dual because, for example, when you say A complement of complement, this is not changed, this is not changed. So therefore, this dual of this one is again complement of A is A. Of course, I can say that this is the dual of this, but both are the same, right? So therefore, we say that it is not having a dual. And if you have exclusive OR, again, there's no dual. So therefore, those rules also comes as a single rules. So that is set notation. In logic notation, what happens? Because intersection is N become O, become N. N become O, N become O, and if you have O become N, right? So N become O become N. False become true, true become false. Again, don't touch not. Not you, not the again, not you. Pay not. Method not you, no method not you. Not take up the animal. False to velatino and o velatino, o and velatino. So don't touch and. And also, if you have XO, don't touch that. XO එකට අත තියලා ඩන්න. AND එකට අත තියලා ඩන්න. Dual ගනින්න. ඒකන්ත ඒවයි dual එන්නේ නැහැ. Right. So here you can't change it. Okay. Right. So therefore, that is how you get 23 odd rules, because most of the rules are 2 rules. So therefore, though we say it's 23, it's something like about 10 to 12 rules. So therefore, it's not difficult to remember, because if you write the rule, you can always write the second rule. So therefore, if you know the 10 rules, basically you know 20 rules. So therefore, don't think that it is hard. And don't ever think that these are difficult things, and right, because the logic is the thing that you use, right, day by day, every minute, every second. So this is a very important thing. So what do you mean now? How often you use numbers? How often do you use numbers? Like 5 plus 2, 3 into 4, numbers, arithmetic operations. For example, today, how many times you have you used arithmetic in your life? From morning to up to this point. Anyone? So from morning where you get up to this point, how many times you have used arithmetic? Anyone? And you have to give, you must give me the many times, right? So can you give me one examples where you use arithmetic during today? During today. අද දවස් ඇතුළත arithmetic පාවිච්චි කරපු තැන මට කියන්න පුළුවන් නම් කියන්න පුළුවන් නම් ඒක ප්‍රසිද්ධිය කියන්න පුළුවන් දෙයක් නම් විතරක් කියන්න නැත්නම් කියන්න එපා. Watching time. Okay. Anything else? වෙලා බලන arithmetic පාවිච්චි කරපු තැන how many times you watch time? For example, you maybe it's till 12:55. I have 5 minutes more to go to the class. So that is use of arithmetic, right? Buy goods. Yes. ඔයා කඩේට එහෙම ගියා නම් arithmetic පාවිච්චි කරා නේද? Maybe you bought something 650 rupees. So you gave 10,000. So you know that I'm supposed to get 350. How do you know that? Using arithmetic. Correct. Maybe one times. Right, collect coins in my purse. මගේ purse එකට සල්ලි වැඩියෙන් වැටලාද කියලා බලන්න නැති උදේ වෙනකොට. Right, correct. For example, I made a cup of tea today. So I counted how many, right, spoonful of sugar to add, or maybe milk to add. මැල්ලනේ දාන්නේ දෙකක්ද තුනක්ද කියලා. So that is we use arithmetic. Okay, how much weight did I lose? So that is very good. So that means you are conscious about your weight. So that is good. That you can get the weight එක මයින් තරාදියක් තියෙනවා. So that is very good. ගෙදර තරාදියක් තියෙනවා කියන්නේ සාමාන්‍ය මහත් වෙන්නේ නැහැ. ගෙදර තරාදියක් තියෙනකොට ඔයා දන්නවා මේ බර පාලනය කර ගන්න ඕනේ කියලා. මොකද අපේ මිනිස්සු වාහනයට ගිහිල්ලා උලන් චෙක් කර ගන්නවා. හරි? වෙලාවට ගිහිල්ලා තෙල් මාරු කරනවා. තමන්ගේ ඇඟේ බර ගැන හිතන්නේ නැහැ. ප්‍රෙෂර් එක ගැන හිතන්නේ නැහැ. So that is good. ඊට පස්සේ කල්පනා කරනවා හරි body mass index එක කරනවා මම ඉන්න ඕනේ මෙතන. හරි තව කොච්චරක් මම අඩු කර ගන්න ඕනද? තාම හොඳයිද? So that is good. So that is use of arithmetic. Right. So then what about how many times do you use logic? How many times do you use logic? From morning to now. AND operator, O operator, XOR operator, NOT operator. මම නම් උදේ පාන්දර නැගිටින්න Boolean logic එකක් දාලා තමයි. නැගිටින්න. Something like if it is past 6, I will get up. If it is not past 6 yet, maybe still 5:30, I'll think of, okay, I'll stay a little bit longer in the bed. So that is a logic. Maybe if it is Saturday, I do this. Or weekend, I will do this. If it is a weekday, I will do something else. Logic. If it is raining, maybe I'll go for a coffee. If not, maybe I will go for a tea. So it's all logic, right? And logic, co-logic, not logic. So how many times do have you used logic? Say cross the road. Are there vehicles from the left? No. And are there vehicles in the left, right? No. I'll cross. Okay. O එකම දැම්මනම් එහෙම හැපිලා. දැන් and එක දානවා දැන් O එක දැම්මනම් එහෙම මොකද වෙන්නේ? මේ වෙනකොට ඉතිරි දාන්න. No vehicles in the left or no vehicles in the right. I will කියලා දැක් ගියා නේද? දැන් රොබෝ කෙනෙක් ප්‍රෝග්‍රෑම් කරනවා කියන්නේ and එක වෙනකොට O එක දාලා ප්‍රෝග්‍රෑම් කරනවා. වමෙන් වාහනින් නැත්තම් හෝ දකුණින් වාහනින් නැත්තම් පැනපී කියලා ප්‍රෝග්‍රෑම් කරලා යනවා. මේක කුඩු තමයි අරන් එන්නේ. You can see that maybe every 10 minutes we use some sort of a logic. So therefore we must be very sure about our logic. More serious than arithmetic. More serious than arithmetic. Because if you do 100 arithmetic operations in a day, we do 10,000 logic operations in the day. Definitely more than 10,000. So therefore, be very serious about logic. So that is what I want to tell you. Right. So next class, we will discuss these rules and then we will move on to the digital logic circuit design. But the more important thing is not digital circuit design, understanding logic. Okay. So that more important thing we have already done. Right. So for the set of students, you have both for the batch 2, you don't have evening session, but for the batch 3, you have a evening session also, right? So batch 2, you have only this session today because you will be having evening sessions after a few more days. But batch 3 students, remember you have 7 to 10 session also, right? Right. Please stop. How to join the Google Classroom? If you haven't got the Google Classroom invitation mail, and if you have done your first installment payment or the full payment, and if you haven't got the invitation, just send me a message with your Gmail address. I can double check what is the issue is. Okay, simple as that. But make sure you send me a message. Okay?
I have little bit doubt in logic gates, sir.
Yeah, but what is your doubt?
If 0 is current won't flow, if 1 is current will flow, right, sir?
Yes.
Does that mean XOR gates, both sides are zeros, then how can it generate electricity?
I think I explained that when we did introduction to computer, right? Because you can see only 2 lines, right? 2 inputs and 1 output. But in reality, there's another input, right? In reality, there's another input. So therefore, from here, you get the electricity and that electricity goes. But this logic gate control that when both are 1 only. No, no. What is your original question?
If both sides are zeros, how
both
can
side
it
means
generate
both inputs.
Yes.
Both inputs are 0.
Then how it become 1 in XOR gate?
In XOR gate, yes. So this is XOR gate. When both are 0, it is 1. So the reason is not only XOR gate, all the gate has another input, right? Another input. So therefore, though you don't have electricity here, from this electricity it can goes there. And XOR logic is implemented using the transistors to do something like this. So I think this is in your note. So let me explain it, okay? Not I think, it is definitely in your note, but not for XOR. I have explained it for the NOT gate. Okay, let me open it. I think we discussed this in the class. Maybe you forgot or something. Not for XO, I explained it for the NOT gate. Okay, let me. Yeah, I think still we have not explained. Yeah, maybe we will. Okay, let me double check. Okay. Yeah, sorry, we have not discussed it yet. We will be discussing that later. So it is explained in. No, it is, I think, explained in this note itself. Okay, let's go down. Right, not this one. Not this one. I think it is explained in logic circuit design note. I think that note is already in your Google Classroom. Right, you can see how does NOT gate having output current when no input current? Remember, in NOT gate, when there is no electricity here, right? So remember, because I took the NOT gate because that is the easier to explain. You know that in NOT gate, when this is 1, this is 0. That somehow you may understand. But when this is 0, this is 1. So when there is no electricity here, how can we get electricity here? So that is a valid question, right? So the reason is, this is how you draw the NOT gate, but in reality, there's another input, right? So there's another input. You can see there's another input. So that input will give you the output. Okay. So that is how it goes. So the same is applicable for XOR gate. So though you to see it as 2 inputs and 1 output, there's another third input. Okay. That the third input is internal there. So that is how when both are 0, you can give the output as 1. Right. So do a Google search, do a YouTube search. You will get more information about that, because that is obviously right. So without electricity, if you are getting electricity, so either there can be 2 things happening. So due to some miracle, electricity is generated. Of course, miracles are not part of science. Second reason is your XO gate must have a battery for some sort of a charging. That is also not the case. So therefore, you have another input. Okay, so that input you get the current anyway. All the time that input is there, but depending on the logic only, give the output. Okay, right. I hope that answer your question for some extent. But if you need more details, you need to understand how the transistor works or diode works. Okay, right. We stop at this point, right? Thank you.